Good afternoon. I'm sorry. Good morning. Actually, today is the second day. So normally in the first session, the number of heads are less. But definitely of a particular day actually shows how good the day will be. So this is a very interesting seminar because the seminar is on green steel, and green steel is the buzzword in today's perspective. Everybody is talking about green steel in the field of metals and metallurgy. And obviously the sustainability is a very important part in today's era, because unless and until we can make our mother earth happy, this is a very difficult task to be successful in the industrialization. So today in the first session, the first lecture will be given by Mr. Prashanto Pal, Associate Director and Senior Fellow, and Mr. Shambhit Ghotok, Research Associate from TEDI. And their topic is a very interesting thing. Actually, I used to teach iron making, steel making, and alloy steel making, etc. This is the extractive metallurgy part in our department in undergrad and postgrad. And there always the new things are coming, and especially within the last 10 years. And the most important part, which is present in the syllabus, in the new syllabus, is the green steel, green energy, and decarbonization. And their topic is exactly similar: roadmap for the decarbonization of the steel sector. So I request Mr. Prashanto Pal to start his lecture. And Prodipto, what is the time duration? 15 minutes. So 15 minutes. Actually, in the first session, always we are liberal. And in the end of the day, it is 10 minutes, 8 minutes, 7 minutes, like that. So without any delay, so sir, 15 minutes.
Okay. Thank you, sir. Thank you. Thank you to the organizers for the opportunity. Good morning to all of you, and welcome to the second day. I can see a lot of empty seats. I'm sure you had a very interesting first day. And the topic which we are going to talk on today is basically decarbonization. And from the agenda, I saw that already decarbonization has been talked of quite in detail. So probably some of it will be a repetition of yesterday's discussion. So before that, let me tell you a little bit about TERI, because this may not be fully familiar to all of you. We are actually funded initially by Tata Group of companies, founded in 1974. This is our 50th year. So we are a non-for-profit research institute, and under Section 25, it is a basically under Societies Act, we are registered under that. So institute has grown from very small beginnings from 5 or 10 people in Bombay to now we are about 1,000 people strong, spread all over India, but headquartered in Delhi and Gurgaon area, basically where our campus is, 100-acre campus is there on the Gurgaon Faridabad road, and our headquarters is in India Habitat Center. Those of you who have visited Delhi, I'm sure you might have attended some conferences in India Habitat Center. Both Sambit and I are from the Industrial Energy Efficiency Division of TERI, and we have many divisions, verticals. And in Industrial Energy Efficiency Division, as the name suggests, we work with industries. And we have been working, actually, I have been working with TERI for the last 30 years, more than 30 years now. And since beginning, we have been working on energy efficiency. But decarbonization, which is now the buzzword, is reducing carbon emissions by basically decarbonization essentially means that. And one of the pillars of decarbonization is energy efficiency. So we have been working on energy efficiency. Our group very closely works on energy audits and with industries, large industries, small industries and all. And Shambhit is, for example, a energy auditor with electrical background. I am a chemical engineering background from IIT Delhi. So with this brief background, let us dive deep slightly more into the topic today. And this essentially shows all of basically the importance of steel, decarbonization of steel industry. Because steel industry, for example, if you look at the pie chart, if you look at the various cement industry, pulp and paper industry and all, Steel industry accounts for almost emissions of 40% of the total emissions from the industrial sector. It is a very big emitting sector, and almost 12% of the country's emissions, total country's emissions comes from steel sector. That is the most important sector if one has to, India has to sort of achieve the net zero goal, which is set forward by 2070. And hence, a lot of discussion of government of India, international community is on decarbonization, how to decarbonize the steel sector. There's a lot of uh, initiatives, international as well as national initiatives taking place. Just for, I mean, most of this is available. I can share the presentation. I've shared the organize with the organizers. If anybody wants a copy, I can share the presentation. Nothing is confidential. Our product is all for the public. Most of it is present in our website also. Just for information, we can share the presentation later on. Now, coming specifically on the steel sector, this actually slide gives, which I can't see very well, so I have to look at the printout. What is the growth rate? Another important factor for steel industry production, about 150 million tons presently. This statistics, 144 million tons was last year, 23-24, has been growing at double digits. And the Ministry of Steel also is very proud to tell that steel industry has been growing at double digits, unlike other sectors of the economy, which is growing at 6-7%. Last year's growth rate was 13% almost. So it is very high. The growth rate is extremely high. And one of the reasons for the growth rate is because of the boom in the construction sector, as you know, and this is a hub. West Bengal is a hub of steel, Tor Steel. So many big steel companies are here. They are making mainly for the construction sector, infrastructure sector. These are the main growth drivers for steel, why it is taking place. What is also important, all of you are from the steel sector. I need not mention that DRI is India is one of the largest producer of DRI, almost 350 plants. And that also the coal-based DRI, that is the most biggest bottleneck for decarbonization. That is well understood now. 80% of DRI production in India is coal-based. That is the horizontal rotary kiln. Unlike in the West, Europe, USA, everybody is on natural gas-based DRI. Mostly all are natural gas. Coal-based DRI is only used probably in India or South Africa or some other countries. Very few countries in the world use this kind of technology. And hence it is a big challenge for decarbonization. I'm not going into the technical details. We have an entire presentation on how to decarbonize the DRI sector, but this is more of an entire steel, so I won't spend much time on DRI here. But that is a big technological challenge. Just suffice to mention that some research is going on. Very recently, a pilot plant has been set up um, in South Africa, Namibia, with German technology, where they have tried to actually successfully implemented pilot scale hydrogen-based horizontal kiln DRI, and there's been successful trials of that. It is a pilot plant. It is running successfully. I'm not sure of the capacity. I was told around uh, 50 tons per day or something of that. So it is a pretty big, decent size of pilot plant which is operating. We have yet to get the full details of that. It is a very recent development. Probably it will be interest to Indian audience, and people in India are also watching it very closely. Now, looking at this is already known. I'm sure you have gone through this. I need not go in detail about the kind of mix which we have, number of BF units, DRI units, blast furnace units, and so on and so forth. What is peculiar about India? Probably all of you already know that you are from steel industry. The DRI induction furnace route is again a peculiarity of India. When you talk of DRI based steel making, entire West is on DRI based arc furnace. Only India has indigenously developed, one can say, the technology or perfected the art of making DRI based induction furnace coal based route. And the graph also shows the energy emission intensity of the different routes, and DRI based coal based DRI induction furnace route is one of the highest emission intensive, almost 3 tons per ton of steel. As you can see, very high. What also needs to be mentioned here is that the average emission intensity of Indian steel is much higher, 20% higher than world average. World average is around 1.9 energy intensity tons of CO2 per ton of crude steel, whereas in India it is more than 2.5, 2.54 or around 2.5, which is almost 20% higher. So India, obviously, Indian steel industry is under a big microscope or a big focus rather internationally. Everywhere, whenever there is a conference internationally, the other day there was some conference in Italy also, or in Europe also, whenever the Indian industries are not present, very few industries are present. Everybody, international forums, everybody is talking about decarbonization of steel industry of in India, because that is where the major growth drivers are happening. And as I showed you in one of my previous slides also, the per capita consumption of steel in India is still very low, 98 kgs, whereas in developed countries it is 300 to 400 kgs per person per annum. So it is the growth drivers are India, and so everybody is focusing, wanting to focus on India. Now I don't know whether it is translating into the ground, how much it is translating into the ground, but that is a challenge, and I'll talk about some of the challenges later on. These are the various decarbonization initiatives taken by the large corporate sector. It is heartening to know that most of them, I'm not going into detail here for lack of time, but everybody, the large steel players like JSW, Tata Steel, Jindal Steel Power, everybody is talking of JSPL. All are focusing on decarbonization, and because they see a future for that, and they have announced a more ambitious target than the country's emission, that is 2070. That is very heartening to note that they have announced that target, obviously keeping in mind that if you have to be a player in the international market, you have to do that. Otherwise, there will be some kind of a carrot or a stick approach which will come. Subsequently, it is already under planning, but it can come anytime. And after 2030, I would think 5 years, we have got a good lead time before anything, the carbon tax and things like that are introduced. Here also one of the slide tells about Kalyani Steel. I'm sure all of you are aware of this Kalyani Feresta initiative, where they have used scrap and melting scrap in arc furnace using renewable energy, and they have achieved very low emission, that is the green steel, of intensity of 0.19 tons of CO2 per ton. Zero point 0.2 rather, zero point 0.2 per ton of crude steel. So this is an initiative which already Kalyani Steel has done. Obviously, if you are making steel from scrap and using renewable energy power in electric melting, तो आपको already आप green steel बना रहे हैं. And I have visited some of the secondary steel players in Ludhiana, for example, who are using scrap melting in induction furnace, arc furnace, and they are using actually intensities below 0.5. तो आपको मतलब इंडिया में सेकेंडरी स्टील सेक्टर में स्क्रैप से बनाएंगे तो इट इज पॉसिबल टू गेट ग्रीन स्टील टेक्निकली देयर इज नो प्रॉब्लम एट ऑल to get that. But the problem for a country like India is where is the scrap, because scrap is very limited availability. So one other initiative which we are also thinking, government is also thinking, is how to increase the availability of scrap. So if there is any suggestion around that, we would like to also be a partner in availability in the eastern region scrap. For example, we can also tie up with government or any private entity who would like to become a recycler of scrap uh, in eastern region, for example, because eastern region particularly is scrap, mainly less of scrap is available. So we can partner in that. Now, net zero roadmap. I will drop this. Won't go into details. I don't know how much time I have already taken. Sambit, kitna time reh gaya?
You have 5 minutes.
5 minutes.
No problem.
Okay. Because this is the India initiative, government initiatives, and all of you are aware of this kind of national steel policy, scrappage vehicle scrappage policy, national green hydrogen mission, so on and so forth. These are national level policies. Government has taken a lot of proactive measures. PLI scheme for steel, for example, specialty steel. So things are moving. Government has been thinking on that. I mean, so in a way, it is quite positive. And we have also partnered with Ministry. TERI is a partner with Ministry of Steel in this initiative of greening of the steel sector in India. I'm sure you might have read this report or aware of this report, roadmap and action plan. This was released by the Ministry of Steel last year in September in a function in Delhi. And we have partnered with, we have been a knowledge partner to Ministry of Steel, TERI, where we have actually supported 7 of the working groups. There are 14 working groups which are set up. With working groups were set up, all the industry people were also involved. For example, right from developing the taxonomy for steel, CO2 emission monitoring of steel, how it can be done, demand creation for green steel, energy efficiency, renewable energy, material efficiency, circularity, all those kind of things, CCUS, biochar, R&D initiatives, financing, international focus, skill development, skilling. So these were discussed all over 2-3 months, or I think it went over 6 months of discussion, several working groups. Then it was consolidated, and a huge report. Now it is a voluminous report, maybe 300-400 pages, has been released. It is downloadable, freely downloadable from Ministry of Steel website. But decarbonization of steel, which is the topic, actually, we are running out of time, but these are actually essentially, these are analysis done by TERI. Let me mention from now on, it is not a government analysis, is we have done analysis of what are the different ways of decarbonization if we have to reach net zero. Now, if I take you from your right-hand side and upwards, I mean, sort of, or in material efficiency, reducing the material usage of steel itself in the production design, in the construction or whatever, or replacing steel with alternative material, that can contribute to about 10% of savings of CO2. Electrification, these are new technologies, not now, but after 20, it is under development, electrowinning and things like that, HYSERNA or other technologies. These are electric technologies can reduce about 10%, 9%. And it is possible to do that. Of course, this is after 2040. This won't come immediately. Energy efficiency, where we are focusing right now, TERI is focusing our work on, is 11% saving is broadly possible in across steel sector. Circularity, that is use of scrap, about 18%, huge lever, again 20% saving almost by using scrap, higher use of scrap. CCUS, this is post 2040 again under development technology, but it will actually reduce, take away the, for capturing the CO2 from blast furnaces and so on, CCUS, almost 20%, a huge lever again for decarbonization. And green hydrogen about 30%, again a big lever. So the biggest lever, if we have to talk of decarbonization of steel, just for recall, is green hydrogen number one, at number one place, CCUS at number two, and then circularity or scrap usage. So this can actually reduce almost 60% of the emissions from steel industry. These are the big levers. Of course, there are challenges. It is easier said than done, hydrogen and all, because as I told you, the technology is still under development. Green hydrogen, DRI making, particularly when we are talking of, is still under development. I mean, it is already developed, but it is not fully commercialized, I would rather say. It is developed and demonstrated in Europe. I can see I'm running out of time, but this is actually, if we look at the roadmap, we have drawn a graph also about the different levers, which essentially, and the bottommost graph actually, which is in blue kind of thing, is actually decarbonized. So we are actually trying to reach net zero by 2070. And how the different levers stack up, these 5 or 6 levers which I talked of, and contribution of each lever up to 2070. This we have taken forecasting that steel production will rise 5 to 7 fold by 2070 at the steady rate. All that is we have taken the population growth rate figures. So this is a modeling we have created. This is a TERI's model. I mean, it is not taken from other sources. We have developed this own model. Our detailed figures are available with us. So what can be done to each lever. The final slide essentially talks about the challenges and recommendations. The most important challenge, as I mentioned, is technology. That is the RD&D kind of thing. Let me mention that first, because of the hydrogen, green hydrogen, such a big lever. Catalyzing research development, that is the last slide here, the last point here in this. Oops, sorry. R&D. R&D is the last slide, but there needs to be focus. There's less focus on that. If you look at policies, Of course, the policies is a big challenge. For example, lack of common infrastructure for CCUS, common pipeline for hydrogen and all, and things like taxonomy for steel. So the kind of support from government for CCUS and green hydrogen is a key lever, again, in the policy thing. If we look at financing, again, the most important lever is cost of finance. I'm sure all of you, unless it is economic to produce green steel, it can't mobilize. So low cost capital subsidy kind of thing, low interest rate, things like that for de-risk investment in green steel. Essentially, anybody producing green steel at this point, the government needs to think of de-risking the investment, and if some kind of risk guarantee fund and things like that are talked of, and business models, how to promote use of scrap, so on, circularity in the Indian system. And of course, on any of these initiatives, we are working, TERI is working on all the initiatives with various partners, both nationally and internationally. And in case any of you from the industry or other academia would have any other ideas or think of collaborating with us, we are happy. I mean, we are open to networking, partnership as a knowledge provider, and on a non-commercial basis. Most of our activities are for the decarbonization are funded by international sources, not government of India. So we can do this kind of support for people in Eastern region almost without any cost to them, and we'll be happy to support you on those activities. That is all I wanted to. But before I end, let me give some words to Sambit also, because we are doing some initiative, and let Sambit explain a little bit about what we can help you directly, immediately with. Sambit,
Yes.
over to you.
Shumbit, please. Actually, you have already covered 17 minutes.
Okay, okay.
So
You just cover in 1
okay,
minute.
no problem. Please, please.
We have been doing energy audits and energy efficiency studies for the 30 years in Eastern region and all over the India. So there are many entrepreneurs are here. Those who want to collaborate with us in this region. Our major focus is in West Bengal, Chhattisgarh and Odisha area right now. So if you want to collaborate with us regarding the study and all, you can contact us. We can connect with you and do the energy assessment study. Thank you.
Okay, that brings us to the end of today's presentation. I've overshot my time. Thank you very much for your attention. Thank you.
Thank you, Mr. Pal. It is really a very beautiful presentation, and I will love to take it and show it to our students because a lot of data are there. And definitely, circularity is the most important thing in present day steel dynamics, because we don't want that our steel production goes down. So we want a higher steel production with a lesser amount of CO2 emission and other SOx, NOx emission. So this is a very important thing. Yes, the cost of green hydrogen is very high. Obviously, forget about green hydrogen. We are not producing blue hydrogen as well. So we are still sticking black or brown. But anyway, definitely, Mr. Pal has shown that a group of very big industries, they have already initiated to decarbonize the entire thing. So definitely we will succeed. Thank you. So our next speaker. Yeah, after the session, this then everybody, it will be open for discussion, the floor. Growth prospects for coated steel in India. He is not here. Mr. Sachin Shetty. He is not here. Okay. Then Indian flat steel market overview. Suhita Poddar from Kalanis Commodities. Yeah. 15 minutes. Okay. Yeah.
Hi, everyone. I'm Suhita Poddar from Kalanesh. I want to start off by saying I hope Mr. Mukherjee a very speedy recovery. And today I'll be discussing this Indian flat steel markets overview. I wanted to start off with a little bit of context setting, essentially to show the importance of India, not just for us here discussing the steel sector, but also on a global perspective. The reason being that it's the second largest crude steel producing country in the world. It's also the only country registering a positive growth rate in top 5 steel producing countries. What's been driving this change is very strong macro indicators, government initiatives. There's a huge push on infrastructure projects. There's a lot of demand from end user sectors as well, like infrastructure, construction, manufacturing, automotive. So on a ground level, the fundamentals are pretty strong, even though currently there are some headwinds, which I'll get into later. There has been some changes in fiscal year of 25 and now 26 as well, mainly domestic market being impacted by imports. However, with the onset of the safeguard duty, there's been lower imports so far, but currently there are still some challenges that India is trying to overcome at the moment. Here I have included the current HRC, CRC plates, hot dip galvanized, and also pre-painted coated galvanized prices. As you can see, prices have been trending higher between Jan and April. The reason being there was a lot of rumors circulating about the safeguard duty, which caused prices to spike. And finally, with the imposition of the safeguard duty, that helped keep prices higher. However, since May of this year, there's been a bearish trend in HRC and other flat product prices because of a seasonality. It's generally weak demand because of monsoons, and also the early onset of monsoons, which impacted prices as well. And of course, tighter supply or expectations of oversupply following tighter supply due to maintenance shutdowns between April and May of this year by various mills. We're seeing a similar trend in export prices as well. Prices trended higher between Jan and April of this year because of Indian mills being unclear whether AD duty would be implemented on India during that period. Of course, now we know that India is exempt from these AD duties. And also, despite having lower safeguard quotas, the impact of having clarity in AD policy helped lift export prices. Also, there was a focus on the Indian market, which led to prices trending higher as Indian market was stronger compared to international markets. However, as we saw in the domestic market, flat steel prices and exports also trended lower since May onwards because of persisting weak EU demand and, of course, very strong pricing from Asian suppliers to the region as well. I wanted to touch very briefly on CBAM impact. Very recently, we received a CBAM simplification from the European Parliament, which was approved. I've listed out what the changes are, which essentially is that a minimum of 50 tons per year per importer needs to be the threshold for CBAM to be exempted from these exporters, which applies to about 90% of small and medium exporters to the EU. However, because Indian exporters usually tend to overshoot this amount, CBAM still applies. Gathering a lot of primary research, I found out that EU buyer sentiment still tends to be very cautious. Because of this, there is still hesitancy to buy hot rolled coil at the moment. I'll give you more data on that later on. But overall, the estimate of CBAM for HRC, I can't really see my slides from here, so I'm trying to see from here. But overall, the CBAM impact for HRC is about 80 euros per ton. And for CRC and GALV is about 70 to 100 as per EU calculations. Indian exporter sentiment at the moment for CBAM impact is still undecided. Most of the people I've been speaking to, or at least the primary research I've gathered so far, it's unclear at the moment. However, despite not having too much clarity on what the implications for this would be, overall, it seems that it's still very unchanged, and what was the situation prior to the simplification approval still stands. So it's essentially being considered largely procedural, although again, they're still waiting for a lot more clarity and information at the moment. And finally, why are we talking about green steel today? How does India play into it? First, I want to touch on this report that recently released by GEM. Essentially, it shows that India impacts not just Indian steel industry's green transition, but also globally. The reason being, India currently leads in capacity expansion across the world, surpassing China. I've listed some information here. Again, it's very hard for me to look at the slides, so I'm just going by the larger numbers that I'm seeing. Secondly, despite leading in capacity expansion, it's lagging in execution. What this means is there's a huge opportunity for decarbonization because a lot of the projects are still adjustable. So what India decides in terms of the green steel plant investments or which plants are or whatever the upcoming projects are, it matters not just for Indian steel sector, but also globally. I've listed out a lot of the green steel measures in this and the following slides as well. However, since it was very well covered by my previous speaker, I will not delve too much into it, and also we're a little short on time. What I essentially wanted to highlight, though, is that now there's been several new policies, starting with the net zero announcement of 2070, which Mr. V.R. Sharma touched on in the previous day as well. And also green steel taxonomy and green steel, the hydrogen mission, and the other ones that I'll be touching on later on. However, the key challenge of having low accessibility to high-grade iron and other challenges still persists. I'm skipping over this because this has already been covered by the previous speaker. Wanted to touch very briefly on what the future outlook is, not just for the domestic market, but also exports as well. The outlook for prices, at least for Q2, is bearish, largely because of seasonality, obviously. However, I also wanted to very briefly touch on safeguard duty. What we're seeing since its imposition from 21 April is it's been partially effective. There have been lower imports. A lot of data suggests that HRC imports have reduced since the announcement and since the imposition. However, we are also seeing alternative sources of importers coming into India, such as Russia, and also different ways of Chinese material coming into India, such as using advanced licensing. This indicates that while there is lower imports happening in India, it's not been very effective. Currently, I'm sure everyone must have heard there's been rumors going on that safeguard duty could be increased to 24%. It's unclear if it will be imposed anytime soon, and even if it is, it's unclear if it will have a significant impact. It will lead to import levels being unviable on a landed price basis. However, until the fundamental issues of demand and supply are addressed currently, it's not really going to challenge the market too much. Finally, very briefly, wanted to touch on US tariffs. Obviously, we know that it will have an indirect effect because it leads to trade flows being shifted to different regions, perhaps more Chinese material coming into India or other regions. However, there's also some direct impact being seen with a lot of engineering exports being impacted as well. We're also seeing more protectionist measures because of more imports happening, which is tighter compliance, such as BIS licenses, QCOs, and of course, the recently updated domestically manufactured DMISB policy. Finally, discussing the export market as well. Prices look bearish, because again, demand in the EU and in other regions is pretty weak, and there's very strong competition coming from Asian suppliers as well, which I touched on earlier. However, green steel compliance costs, excuse me, green steel and compliance costs may rise. There's also shifting trade flows, and of course, shifting product offerings. This is something I wanted to touch on here as well. There's been a trend in the last 6 to 9 months. I wanted to include that table here, but I didn't get a chance to. what we're seeing is that the safeguard duty quota for India is not being utilized for HRC, primarily earlier because of the lack of policy clarity on anti-dumping duty. But now it's because of also, in addition to possibly CBAM and the EU looking at how much quota is being used, in addition to that, there's also more demand for value-added products. So we're seeing more quota usage of safeguard quota usage for HDGI, PPGI, and to a lesser extent CRC versus HRC quotas being exhausted. Some of the key watch points I want to highlight are some of the key factors that will affect export markets are, of course, what's happening in the international markets, oversupply in China, and of course, exchange rate policy. I try to keep it within the time limit. I think I have. Just very briefly on what we do at Kalanish, we cover news, we cover events, reports. Here's a list of the different types of things that we do: daily news, reports, prices, reports across different countries, different products, and of course, events. If you have any questions, please feel free to ask me or reach out to me. Thank you so much.
Thank you, Ms. Poddar. This is really a very interesting topic. You have talked about the Indian flat steel market. It's a very good overview. India's growth drivers, the both change in domestic and export price, the carbon border adjustment mechanism, the role of which is very important in today's export of steel products. And obviously, you have talked about the government initiatives. And one thing is there, this is very, I have just saw that the project implementation rate in India is very less. I don't know why. Probably the growth rate of India's steel market is very high, and in today's perspective, change to newer technology may hinder, I think, someone may think that it can hinder the growth rate. But definitely, we have to make a sustainable growth where sustainability needs to be looked out along with the growth rate. So this is a very important thing. And as I have told that after this session, we will have a question answer session. So thank you. So our next speaker is, I don't know whether he is present or not, Dr. Mithileshwar Yadav. He is not there. His topic was jet vapor deposition. So our last speaker in this session is Mr. Nandan Shatra, Head of Technical Marketing Lining Business, RHI Magnesita. And his topic is again very interesting: decarbonization and carbon footprints for Indian refractory industry. Mr. Shatra.
Yeah. So, good morning, everyone, distinguished guests, delegates, and dignitaries. And I really thank organizing committee to give an opportunity to speak something on the recent topic, that carbon footprint for the industries. You know, when steel industry wants to do something, it's not just alone. The steel industry has to take all the associate industries or its vendor and supplier, because one of the important associates is, of course, the refractory industry for the steel, because refractory industries also emits a lot of CO2 emission in the atmosphere while processing of refractory. And out of the whole refractory, as you know, 70% goes to steel industries and around 12% to cement industries, and followed by rest of the industries. So it's not just steel industries. It's a common goal. I just quickly come across that the correlation between the CO2 and the economic growth. You know, today, India is the fifth largest economy in the world, but there is a correlation. And in terms of CO2 emission, India is the third largest contributor of CO2 emission. You can see here, it's after China and US. But the major difference is that the US economy, being the largest economy in the world, their economy based on the service industry. If there are three components of the economy: one, the agriculture base, agriculture, then industry, then services. So more or less 85% revenue comes from the service for the US. But what is just opposite in case of China? China, its manufacturing based industries, and followed by India is another largest manufacturing based industry in the world. And naturally, when any economy based on manufacture, obvious reasons to emit more CO2 in the atmosphere. And I just vis-a-vis put some data on the steel production. You know, as somebody was mentioned in the morning, that the steel industry produced 40% of the CO2 emissions among the all put together. So here I just contributed the country's contribution vis-a-vis steel industry's contributions. You can see in the graph that that the 13% contribution from steel industry from China. US is the lowest. It means they have the first reasons I mentioned, their products, their economy is service based, not the manufacturing base. Even the manufacturing, they are not strong enough in the steel. They are into oil and gas, they are into chemicals, they are into other industries that emit CO2 much lesser than the steel industry. That is the percentage wide CO2 is much lesser in case of one. See, come back to our refractory industry. Just before coming to refractory industry, you can see the world average for CO2 emission is around 1.92 kg of CO2 to produce 1 kg of steel. Or in terms of tonnage, CO2 steel industry emits about 2 ton of CO2 to produce 1 ton of steel. Vis-a-vis the refractory also, it produces globally world average 2.1 kg of CO2 emits to produce 1 kg of refractory. And if we bifurcate the three parts, the major contributor, which is a direct contributor from the raw material of the refractory, and then the indirect contributor that that is a logistic transport, that we send material to different place, and another direct is from raw material, and direct from the processing of the refractory. So coming one by one, where we can do this is the valuation of the typical valuation of the refractory industry. We get the raw material from the mines, then we process it to calcine at a higher temperature, particularly magnesites and the dolomites, fired at relatively higher temperature in between 16 to 1800 degrees Celsius. So in the process, it emits almost 50% CO2 in the atmosphere. And then we process it, then it's pressed, then we fired it, then we do the quality inspection and checking, then we apply at user industry like steel, aluminums, metals, and the cements, glass. Then after use, then we dismantle that refractory. Then after dismantle, again we collect in a particular way so that we can reuse those material to the process again, of course by proper treatment. And that is all about the circular economy in the refractory industries. So in short, as I mentioned, about 2 kg CO2 emits to produce 1 kg of refractory. Normally, it's a direct correlation. If you use more and more recycle in the recipe, your carbon emissions will get reduced almost directly proportion. So for 2025, globally, we have the target 15% recycle to be used for the productions we have. And because last year we achieved 14.5, so this is very pragmatic, very, very easiest way to achieve this target. And you can say the reductions is also 15% CO2 will take place. I was mentioning that the contributor on the whole refractory process steel applications, approximately 82% CO2 emits from the raw material, as I mentioned. From the ecological point of view, if you ignite 100% raw material, 50% it goes to CO2 and 50% to your actual minerals that you get. So 80%, 80 to 82% approximately come from the raw material. Approximately 9% CO2 emits during processing of refractory. As I mentioned, like steel, refractory also produced at very high temperature, more in between 1500 degrees Celsius to 1800 degrees Celsius. So to rise the temperatures, there must be some fuel, there must be some binders in the systems that emits a lot of CO2 in the atmosphere. Then, as I mentioned, that the transportation and the indirect fuel. From RHI Magnesita, we mention CO2 emissions, or you can say the carbon footprint for each and every product we produce. The green steel producer, whoever over concerned about the CO2 emissions, for them, we have various solutions. For single product, we have 2-3 category that gives the different level of carbon footprint for the same product. Because any product today, when particularly Europe and US, they also started mentioning CO2 emission in their product. So from RHI Magnesita, we took that initiative and already implemented in 2023. Every product we produce, we mention CO2 emission. So just an example, anchor heart, that is the bottom heart of electric arc furnace. That's one of the strong brand of RHI since last 50, 60 years, anchor heart brand. We mentioned that 1.7 kg of CO2 emits to produce 1 kg of anchor heart material. So steel maker, if he has some calculation or maybe he has some target to achieve certain CO2 target, CO2 emission target, he can control or select the product based on the carbon footprint. And CO2 emissions takes place for different product line. For example, if it is alumina systems, the CO2 emissions is much lesser because the impurity is much lesser in the alumina based product, alumina silica based product. In refractory industry, primarily there are 3 products. The basic, that is magnesite and dolomite, and non-basic, which is called alumina, that is the bauxite based material, and the acidic, very rarely used, few cases only for the coke oven battery, that is for silica refractory, silica. That does not emit too much of CO2 emissions. For if you go for alumina or silica systems, which is recommended from the refractory industry for steel industry to use as much as possible alumina silicate based system solution, because that gives the bare minimum CO2 emissions from the product. But if you go for the basic like magnesite and dolomite based product, that gives the highest level of CO2 emission. You can see in the graph that MgU, that is called magnesia carbon, gives approximately 3.5 to 4.5 CO2 emission, 4.5 kg CO2 emission to produce 1 kg of refractory. I was mentioning there are 2 kinds primarily responsible. One is the ecological point of view. Let's say magnesite, magnesium carbonate, if you ignite it, it's MgO, that is the refractory, because refractory always used in oxide form. And then CO2, it's almost 50% emit CO2 in the atmosphere. Then you use the fuel to ignite or to sinter those material, either in your furnace, either in your kiln, or in any direct combustion systems. So here also calculations, because historically or traditionally we have been using coal and gas producer based industry for the refractory. Now we have switched to oil and natural gas, and now most of the company, even in the global, are gradually using the natural gas. The only reasons you can see here, the natural gas gives the lowest CO2 emissions in the atmosphere compared to coal, coke, or any other fuels available. So today that is the best options. That is why the US is another region, because they have the best quality natural gases. India we have, but the limited use. Where the refractory industry mostly located in the eastern part, like the steel industry also located in the eastern part. So natural gas availability is a question. So that is why we are not able to achieve 100% usage of natural gas for production of the refractory. But the tendency is such that if we could use more and more, then definitely CO2 emissions during processing of refractory will be reduced to some extent. Now, decarbonizations, what the steel industry was saying since yesterday morning, we are also committed for the decarbonizations. Decarbonizations, there are two parts. One, that you emit the lesser amount of CO2 in the atmosphere, and for that you need different technology. And second, whatever you have emitted, that you can process, you can collect, store, process, and again release the clean gas to the atmosphere. That is the decarbonization. And from Aricha Magnesita, we are committed to do that. And two reasons, or maybe two concern for India. India, whatever refractory supply to the steel industry, particular for the primary and the secondary steel processing, the raw material base is dolomite and magnesite, which are coming from outside India, primarily from China, and then Turkey, and to some extent from Brazil and Europe. And that is the reason India doesn't have much concern on the raw material, on the CO2 control on the raw material part, since it is imported material almost 80 to 85%. Alumina systems we have, because the Gujarat is the regions where we maximum collect or processing of bauxite, that is also used in alumina systems of refractory, but also import high volume of bauxite from China. So it is not related for India at the moment, except using more and more recycle in the process. So now, globally, what we do today, we do the conventional way. For India, let's talk about India. At the moment, we are, as I mentioned, it's directly proportional. If you put more amount of recycle in a controllable way in the recipe, you can save more CO2. You can reduce lesser CO2 to the atmosphere. Second, as I mentioned, if we switch from basic system to neutral systems like alumina silicate, then also reduced your carbon emissions. Today, JSW and Tata Steels, if you are from the steel processing background, I know many of you, you know there is a recent changes took place in last 2 years, that the magnesia carbon used to apply in the slag zones now getting replaced by spinel bricks. And spinel is just alumina spinels, only 4-5% of MgO in the systems because of the carbon pickup and other issue. And that gives much 20% better life than the magnesia carbon. So that the changes already took place, which is the ongoing process. So that is the way we are also doing. Second, electrifications, you know, if you switch from oil or gas producer to electrification, then also CO2 emissions can be done. The last point, which is CCUNS, the carbon captures, utilization and storage, which really do not do anything from the, as of now, from India, from the refractory side, I know, but globally, Aricha Magnesite started doing some activity on CCU, and we did the partnership with the Australian startup called MI Carbon. They are very good in CO2 initiatives and capturing and process. What you can do, if you can capture and process CO2, there are also amples of scopes to use that CO2 into product. Product means CO2 must be knowing the food grade CO2 also used in carbonated water. In Europe, many people takes the carbonated water, and also you consume Pepsi and Coca-Cola. That is also part of the recipe is carbonated water. So that you can supply to the food industries. Second, CO2 you can utilize for mineralizations like magnesia carbon that is used, or magnesium hydrocarbon that is being used for paper and pulp industry, ceramic industry, whitewood industries. And then also you can use that CO2 to produce the biogas. Because if you capture CO2 in terms of liquid or in terms of gas, then you mix with the hydrogens, you can create the biogas. Here the principle, I
Mr.
just
Tatra.
have 4 minutes more. CCU process that we are talking about, that the cryogenic carbon capture. You know, if you do the 2x2 matrix in the phase diagram, after certain pressure and temperature, CO2 becomes solid, and at 1 point particularly minus 78 degrees Celsius, and 1 bar it becomes solid. Even if you increase more pressure and temperature to a certain within a range, it's becomes solid. After that it becomes liquid, and after that it becomes solid. So from the industry, including from the steel, including the raw material of refractory, if we collect that flue gas and pass through a heat exchanger, then put it in the particular pressure and temperature, then there will be a separator. The CO2 in solid form, it will be separated and will be collected from the bottom, and all other gases that will be separated in the top. And again, you collect it, if you pass it through the heat exchanger, then you can create a clean gas that you can emit to the atmosphere. So there is no CO2 in the clean gas. Now the CO2 you collect in terms of solid, then you process through heat exchanger, you convert it into liquid, and if you liquid, you can store somewhere, you can use those liquids in different applications like mineralization and food processing industry. I'm not going into details, I'm skipping this slide. The same thing I already mentioned. Now, what about H2 at Aricha Magnesita? Honestly, at the moment, we are not doing anything for the H2. We are just focusing on the CCU, carbon capture and utilizations. And for us, as I mentioned, why not focusing? Because as of now, even we do not know how refractory will behave under hydrogen atmosphere. If you use the hydrogen as a fuel, alternate fuel for the calcination or sintering, then how the refractory behavior will get changed, we still not known to us. But still research is going on, and whether in the how the refractory will behave under hydrogen atmosphere through burner, or maybe in the whole environment during application, during processings, not yet tested. But for CO2, we already invested 10 million euro for the MI Carbon Australian company to set up a pilot plan how to capture and utilize the CO2. I'm not going to the challenges part, because in India you already mentioned there will be separate pipeline for CO2 and hydrogen gas. There will be massive investment for the capex, and there will be storage or transportation of the H2 and CO2 gas. So at the moment, whatever the steel industry plan 30 years after 2050, or maybe till 2050, we are aligned, but from our side, not focusing that much from India side. Now, what we do from Aricha Magnesita already mentioned, we just do the conventional way that I already mentioned. Second part, green carbon capture. The third thing, which is still untapped, that do something together with steel producer. Like we mentioned, if we shift like IBOS, instead of some bricks used, if you use IBOS, then the CO2 emission should be lesser. If you use some basic system to aluminum silicate system, then the CO2 will be lesser. So the complete solution, or we say it's integrated solution to refractory industries to save CO2 emissions to certain extent. Sorry. Just one challenges or maybe message for the steel industry. Today, what happened when we collect the spent refractory from the after applications, few cases we do control way, because we have total control management, we call TRM, for the full length service management with that steel producer, like we have Sunflag, we have Joshua Nico, and also we have total refractory management particular area like steel, ladle, or maybe BOF, or maybe arc furnace. But what happened, there are many steel producers, including Tata Steel and JSW, they collect improper way. There is no, because they give this job to third party, and when it gives to third party, of course, the economical reasons, they also going to the open market, and while collecting those spent refractory, there is a high chance of mixings of all those grades, because that is the takeaway. If you, during dismantle, if you keep basic part separately, alumina part separately, there is the less chance of contaminations that we need to avoid. So that is why steel industry has to make partnership with the refractory producer, because they are concerned about the quality. This is not something new for India. India used to use recycled material since last 30, 40 years, but that is for the economic reason, not for ecological reasons. Today, we started thinking ecological reasons because if you more CO2 recycled material, it gives the less number of CO2 emission to the atmosphere. So without compromising quality. And that is why these two stakeholder has to align each other. So there should not be any third party who chance of quality compromise and other things will be messed up. So this is the things. Thank you very much for your questions. Nishin.
Yeah, thank you, Mr. Shatra. This is indeed a very in-depth analysis of the sustainable refractory production. You have talked about our limitation because raw materials are mostly imported from China, we have to change the type of refractory to be used from basic to neutral or acidic, like alumina and alumina silica. And again, you have talked about how you have changed from coal to oil and natural gas. But yes, in eastern sector, in eastern area of our country, the natural gas availability is a question. And yes, this needs to be carried out in tandem with the steel sector, the ferroalloy industries, the refractory industries, because without their support and their application, the steel industry cannot sustain at their will. So yes, definitely this is a very important part of and challenge in our future. So thank you. Now I request the audience to ask questions to our dignitaries and speakers.
Good morning. Anand Jha from Mekong. My question to Terry, that you are associated with Ministry of Steel, and India is aiming 300 steel capacity by 2030, in which you have seen 60 to 65% through BA-BOF route. Now we are talking of decarbonization, in which use of hydrogen is the prime factor, and hydrogen can be mainly used in DRI. So how you are looking to reduce this CO2 emission? Because we are increasing percentage of BA-BOF route from now 45, 46% to 65%. So how can we decrease CO2 emission?
Yeah, thank you. Actually, we could not get your name. Can you come?
Anand Jha from Mekong.
Okay. Yeah, thank you. Actually, look, we are only knowledge partner to Ministry of Steel, frankly. And I can only tell you that most of the discussions in Ministry of Steel at most of the forums, they are on the blast furnace route, the larger people, because SAIL is under them, and Tata Steel, JSW and JSPL, those people are on board. And till now, the DRI route has not been discussed in the depth it should have been, frankly. Of course, the only challenge in DRI route will be for blast furnace route, let's say, because if you are going to India, as you rightly pointed out, blast furnace route will increase. So even the Planning Commission, Niti Aayog, also has come out with a document that for larger integrated steel plants, it will be have to go for CCUS only. Because for decarbonization of the blast furnace route, presently, if new blast furnaces are coming up now also and it expanding, so CCUS will be the option for decarbonization. For DRI, coal-based DRI, as I mentioned, those technologies are still under development. So probably by 2040 only the picture, 3540, the picture will be more clear about decarbonization of the coal-based DRI. Because right now there are challenges as far as the technologies available, commercial technology available is concerned. But I mean, of course, some of the people like Midrex and Tenova, who are supplying vertical shaft DRI kilns, they are also claiming that we can give for smaller size vertical shaft gas-based, either natural gas or hydrogen. That is available and commercially available. That is what the claim is for them. And with new developments like hybrid project and all in Sweden and other internationally, as I mentioned, so picture will become more clear for the DRI route by 2030 or in 5 years time, frankly. So I don't have a answer to you, but that is the kind of wishful thinking, kind of what we are thinking of, or what people are discussing in that. I can only share with you. Of course, Mecon is a partner to SAIL, and I'm sure you are doing feasibility studies. So what SAIL is thinking, you are more aware of us. So probably you can also share some insights, because we have also visited Mecon R&D center. You are from R&D? Acha.
Metallurgy.
Metallurgy, okay.
Yeah.
Because you can also share what the SAIL is thinking. Because for particularly for SAIL, I think what the direction they take would give a direction to the Indian steel industry also, in a way. And most of Mecon is only handling most of the SAIL contracts. So
Sir, in rotary kiln, there is a problem because if we use hydrogen, that is endothermic reaction. So how we can compensate that heat? After cooling, that endothermic reaction, we have to compensate that heat. So this is a challenge.
but as I mentioned, technology is evolving, and there is a demonstration project recently commissioned in Namibia. The details are not available, as I mentioned to you. What they are doing is hydrogen using in horizontal kiln. That is what they claim is. And for giving heating, there is electrification outside. Heating is done through electrification. So that is the technology there. We have not full details of the technology yet.
Thank you, sir.
Yeah, my question to Terry again. I'm Satish Lavekar from JSW Steel. So first was, you said carbon decarbonization, one of the step as a 10% reduction in steel usage. So since you are advisor to Steel Ministry, this is not good news for us. So you said steel replacement with something else. So what are you thinking as a replacement? Because plastic is having one problem, aluminum and other things, they are more CO2 compared to steel. So rather than some other metal, if you think about increasing life of steel, that should be the better option rather than replacing the steel.
Yeah, correct. No, let me again clarify. We are not advisors to Ministry of Steel. We are an independent body, because only right now, I mean, we have been a knowledge partner to give the right partner only in the greening of the steel report. So we were knowledge partner to them, but ministry as usual, they take their own. You know how the bureaucrats in India function, and so you are well aware of those process. I don't have to tell you. I think now they have hired another consultant. We are not directly not partnering. One of those big four they have hired, and they have placed about 30 people in the Ministry of Steel department. You are not aware of one of the big four. Let me not name it at the moment. They are actually sitting in Ministry of Steel and advising them. And as usual in the state government and central government, yesterday also we visited one state government department here. Only the big four consultants are working, actually. Frankly speaking, Terry is not in the picture because we don't see ourselves in the same. We are a research institute and we want to remain a research institute, actually. Now, coming to your question about 10% reduction, you are right. I mean, we are not what the internationally people are thinking is go for specialty steel, high strength steel, which are not in India. And then you can reduce the quantity of steel you can use in your structures.
Yes,
So,
yes.
so that is the kind of India is not having that kind of high quality steel. So as you are aware, so most of the construction in Europe and all, they have been able to reduce steel because of high quality, high tensile strength of the steel itself. So that is
Yes.
Yeah.
So it is not replacement of steel. It
Right.
is the weight reduction
Weight
and other
reduction.
methodologies.
Yes.
And second part was the increasing usage of scrap. Everybody is talking about it. So how to control like hazardous element, and maybe the scrap will again come from something which you will have to produce. So how to control CO2 at that level? Is there any plan for such activities?
Again, I mean, this is again a very question which is not, there's no definitive answers as of now. Probably from you are belong to industry, you can give a better suggestion than we can, because industry can give a better suggestion. From the government policy is that vehicle scrap policy, for example, in Delhi, it is implemented. 15-year-old vehicle, you have to scrap, necessarily scrap. all 15 years, but it has not led to that much increase in scrap availability as I understand. Because
Yes.
in India, people have different ways. I mean, it goes to B class, C class cities and all that kind of thing. But one has to find ways to increase scrap and process scrap, segregate scraps, process scrap. How it can be done, we don't have a definitive answer to tell you frankly on that. But people are thinking we need to think together with industry. That's why, as I mentioned in my presentation at the beginning, we are willing to work with the government or the industry to look at this aspect and maybe set up scrap recycling centers, which we think would be a key for Eastern region in the next 4 or 5 years. Because if you look at just simply the other day, I had gone to the railway amount of steel scrap which is available, old bridges, I mean, construction, they are just lying there. It is dead. So if only the railways you are able to convince that to recycle, you can actually generate probably 5-6% additional scrap only by targeting the Indian railways. So those kind of things we have to think. We have to think together. Actually, we don't have a definitive answer.
Okay, thank you.
Any more question? Had definitely one of our senior professors in the early 90s, he has told steel can only be replaced by a better grade steel only. Actually, fiber reinforced concretes or polymers are there. They have a superior property than steel, but they have their own problem. They have their carbon footprint, though lesser than steel, but the cost is very, very high. So we cannot think about replacing steel by fiber reinforced concrete within the next 20 or 30 years. Maybe in the next 30 years, there can be a better material. But to me, again, I simply follow the rule, steel can only be replaced by a better grade steel. So thank you. Thank you for the very good session, the first session of the second day. So now I am handing over to steel and metallurgy.
Thank you so much. Can we have some big round of applause for our session chairman as well as our panelist? I request Pradipto sir to please hand over the token of honor and memento to the session chairman, Dr. Rajiv Dey, sir, Professor, Department of Metallurgical and Material Engineering, Jadavpur University. Thank you so much, sir. Applauses, please. We are truly honored by your presence. To our panelists, starting with Mr. Prashant Topal, Associate Director and Senior Fellow, and of course, Mr. Shombit Ghotok, Research Associate, the Energy and Resource Institute. Yes, big round of applause. Thank you so much. And of course, to Shuhita Poddar, ma'am, from Kalanish Communities. Thank you so much for being a part of the session and being a part of this conference. Thank you so much. Also, to Mr. Nandon Shatra, Head of Technical Marketing, Lining Business, RHI, Magnesita. Thank you so much, sir, for being a part of it. I'll request Ankit, sir, to please take over.
Thank you, Poshari. So before we start the next session, I just have a small announcement. We would like to take a moment to recognize a very special group of attendees that we have with us today. They are, of course, the students who have joined our conference. So these young minds represent the future. They are curious, driven, and ready to face the challenges and opportunities of the future. So as a small gesture of appreciation and encouragement, we will now be presenting certificates of participation to our student delegates. I would like to call on stage Aparna Salunke. She is the content and PR strategist at Steel and Metallurgy, and I would request her to hand over the certificates. And I will be announcing the names of the students one by one. I would request you to please come on stage and collect your certificate. So firstly, from Elite College of Engineering, we have Amit Pal. Then we have Arindam Ghorai. Bishal Roy, Debtanu Sarkar, Joy Das, Milan Camilla, then from IIT Kharagpur, we have Anjali Kumari, Argadeep Sao, Debashish Nayak. Are they here today? Anyone from IIT Kharagpur? Is anyone here from IIT Kharagpur today? Okay, then next we have from Kazi Nazrul University, we have Ayushman Kumar Rao, Monty Ravani, Rajkumar Saha, Shoikat Mondal, Shovik Paul, and finally from Jadavpur University, we have Santosh Khan. Are they here? Anyone from Jadavpur University? We have Santosh Khan, Sukalyan Bishui, Devopam Sinha, Anish Roy, and Swarnali Roy. Thank you all for joining us yesterday as well as today. And now I would hand over back to Poshali to start with the next session.
Thank you so much, sir, and congratulations to all the students. Well, we will be merging the coming two sessions together since we have lesser number of panelists, speakers who will be joining us. So technical session 4 and 5 will be together. As session chairman, I would like to invite on the dais Mr. L. Pugazandi, sir, Executive Director, India Lead Zinc Development Association. Welcome, sir, on the dais, please, to grace as the session chairman. As panelists, would like to invite Mr. Shankhodeep Datta, President, Business Development and Manufacturing, Bakur Energy Asia. Welcome, sir. Mr. Narasimham, sir, General Manager, Tech Sales, Hot Rolling, Daniel India Limited. Welcome, sir. Would like to invite Mr. Ashok Vishwakarma, VP Quality Assurance, APL Apollo Building Products Limited. Welcome, sir, on the dais. Would like to invite Mr. Pramod Almore and Mr. Kranti Chittihoti from Kluber Lubrication Private Limited. Welcome, sir, on the dais. Would like to invite Mr. Umesh Vishwakarma, DGM Sales and Marketing, Berger Becker Coating Private Limited. Welcome, sir, on the dais. Would like to invite Mr. Srinivasan Krishnamurthy, Managing Director from Paul Rich, India. Welcome, sir, on the dais. And Mr. Anil C. Mukundan, President, Sales, Craft PowerCon, on the dais. Our session chairman, Mr. L. Pugazandi, sir, is just joining us. Then we'll be starting the session. Yes, we are clubbing the two sessions since a number of speakers are less. So this is a merger of technical session 4 and 5. Our session chairman, Mr. L. Pugazandi sir, is just joining us. In the meantime, you can have tea, and for the panelists, we'll be serving tea over here. Thank you. So there's an announcement. Mr. L. Pugazandi has to leave early due to some reason. So I would like to request Dr. Orgho Mojumdar sir, Director School of Mines, Kazi Nazrul University, to please come and chair this session. Can we have some applause, please, everybody? And requesting all of you who have completed having your tea to please come and take back your seat. We'll be starting the session right now.
Touch it. It's good morning, very good morning. I will be giving a proxy to L. Pugalendi sir, but in any case, proxy is somewhat good when you are in the class. So we are not in a class, but I have, I think, 1.5 hour time. So 6 speaker, I think we will be going for 15 minutes of time. Five speaker. Okay, 15 minutes. It can be extended another 1 minute, right? So without going into much details of any kind of things, whenever the previous session was really good, and my friend Rajiv Dey was comparing this. He was talking about steel is only be replaced by a better grade of steel. Even the sir told us, because we are student of Professor Mitra. So with that respect, I will call upon Shankhadeep Datta, President Business Development and Manufacturing, Baker Energy Asia, and his topic will be industrial captive solar with payback less than 2 years, Baker's turnkey capex model. This floor is yours and 15 minutes. I will give an indication after 10 minutes. Okay.
Thank you, Professor Mujumdar. A very good morning to everyone. I would love to have your attention for the next few minutes when we touch upon a very significant aspect of greening not only the steel industry, but also any kind of any segment of industry, which is basically the energy. Energy, which is a irreplaceable element for running any system or any manufacturing process, is something which needs to be addressed at the very core to turn any process into a greener process than what it is currently. So I come from Becker. Becker is a multinational based out of Singapore, and we have our solar business spread across South Asia and Germany and parts of Europe. So we are a manufacturer of solar modules, the photovoltaic panels, as you call it. We have our manufacturing facilities located in Malaysia and India. And at the same time, we do complete turnkey EPC projects across all the industry segments, steel being one of the core segments which we address. So many of the attendees and eminent speakers like ArcelorMittal are also our customers, whose production process is having Becker's solar energy content, as I see. Please move ahead. Okay, so taking you through the model, the solar model can be presented into, adopted by 2 modes. Next, please. So we have started our journey from the United Nations, inviting our management in the youth delegate for greener technologies. And our objective is to make solar the primary source of energy for all the major industry segments across the world. These are some of the major industry segments where we hold the largest market share in the on-site capex model. Starting from the food and energy, the steel sector like MAN Steel, JSW, Jindal Stainless, ArcelorMittal, and this is the differentiator of the solar technology, the solar model we provide to all our customers versus the grid power supply that they seek for their existing production processes. So as you can see, the 2 major objectives that can be met is not only turning the production process into a greener future, but also reducing the cost of production by reducing the cost of energy. As you see the difference in the per unit tariff of solar on-site versus the grid power supply. And here are some statistics regarding the cost and the CO2 emissions of the various sources of energy, starting from the conventional thermal power to captive waste heat recovery and the on-site solar model versus the off-site solar models. This architecture helps you understand how you integrate the solar power infrastructure that we provide with your existing energy source or the existing energy supply infrastructure. So conventionally, any industry, be it steel, textile, food and beverages, or automobile, will have the grid power supply with their captive generation source. So the solar infrastructure or the solar power plant can be integrated with both running in tandem as a secondary source of power, which is much cheaper and economical and greener by nature. The models that I was talking about are the CapEx versus the CapEx on-site versus the off-site models. So you may have your factory located at point X at any part of the country, and you can install solar within your factory premises, on the rooftop, on the ground, on the land that is available within your factory. You can also use solar power through off-site model, wherein the solar plant is actually running maybe a few hundred kilometers away from your factory. Now, the difference between the two models is when you establish solar infrastructure within your factory, that is the on-site model, as we popularly call it, the cost of generation per unit is less than 40 or 50 paise, which makes it the most cost-effective and cheapest energy solution and source than any other source of energy. Whereas the off-site model, wherein the solar plant is located remotely away from the factory, will end up with a landed cost of energy added with the wheeling or grid transmission charges, which is anywhere between 3 to 4 rupees. So that is the model we target as a OEM, as the global manufacturer of photovoltaic modules and complete solar hardware. We are primarily focusing in our EPC business vertical, the on-site CapEx model, which gives you a payback on your investment, be it whatever scale and size. It may be starting from 200 kilowatt to few megawatts. The payback comes in less than 2 years because of the lowest cost of generation in the on-site CapEx solar model, that is within the factory premises, within your warehouse, within your unit, which is less than 40 paise per unit. So here is a business architecture that we follow as a OEM cum EPC integrator. So it's a completely integrated supply chain, starting from the raw material, manufacturing of the solar modules, introducing automation in the cleaning and maintenance of the solar plants that we install, and then taking the maintenance of operation and maintenance of the solar plants for the life cycle of 25 years. And these are the branded approach that we follow, from industrial to commercial, even to the residential sector that we cater to through our solar studio, which is basically the retail segment. How are we different from the traditional EPC companies or the solar dealers, right? The entire supply chain that we hold is an integrated supply chain with our own employees. We don't leave it anything to the third party, be it installation or licensing, government permissions, and even the post-installation operation and maintenance is done by our very employees, who are all on-roll resources of the company. So our differentiator from the conventional EPC companies and the solar project dealers is our ownership on the product that we manufacture, install, and commission ourselves through our own team, right? So the reliability, accountability, and the response time for aftermarket complaints are going definitely to be far better than any dealer of an OEM, right? So that's the advantage, and that's the edge that we provide to our customers as a OEM cum EPC installer of captive solar plants for the industrial and commercial sector. And that's why you should adopt solar, the model that we provide, as an asset and not as a consumable source of power. Okay, taking you through quickly on the technology part, the installation that is done by Becker at any factory, commercial or warehouse building is a complete non-puncture type installation, since we provide 25 years of long-term warranty on the complete solar hardware, right? Be it the solar modules to the electrical cables, even the mounting structures. We also ensure that your roof factory PEB building is not damaged by any type of puncturing, drilling, or riveting, which might compel you to replace the roof sheet because of rainwater leakages or other problems. So could you play the video one, please? Okay, so this video basically helps you understand the adhesive and clamping type of installation that is done on your factory roof. As you can see, it's a high bond acrylic based adhesive which is applied on the roof sheet profile without any puncturing or drilling. And the anodized aluminum mounting rail is simply pasted on the roof profile without any screwing or damage to the roof. This adhesive does have a warranty of 25 years and a wind load stability of more than 200 kilometers per hour. And back to the presentation, please. So you can see the roof types that we cater to are trapezoidal, standing seam, and any other profile of roof, even the RCC roofs and the parking sheds. So this non-puncture type installation helps you achieve a uniform load distribution without any puncturing and without any long-term damage to the roof, so that your roof sheet life is also preserved along with the 25 years of performance and product warranty that we give with our solar hardware. Here are some other snapshots of our installation, like the one that you see is at D Decor Home Textiles near Mumbai, wherein the vertical wall mounted option was chosen because of scarcity in roof space. So it's a total 3.7 megawatt industrial installation with 700 kilowatt on the vertical wall. And even on the curved roofs, this is our installation at Varsha Foods in Andhra, who is a mango pulp maker. So this is a curved roof installation that we have done. And this video, you can just click on it. No, just click on this. Click on the slide. Demonstrates the mechanical strength of the non-puncture type mounting frame on which the solar panel sits. As I said, this has a wind load stability up to 200 kilometers per hour without any puncturing, riveting, or drilling. So that you understand the care and the responsibility we take not to harm your factory building roof while you execute the rooftop solar project. And here is a snapshot of our board members from Singapore. Our entity is structured around 4 countries. The head office is at Singapore. Factory number 1 is in Kuala Lumpur, Malaysia. Factory number 2 is in Indore in Madhya Pradesh, India. And we have our corporate offices located in Mumbai and Delhi. And our association with the Nanyang Technological University, Singapore, in our R&D, back-end R&D in Singapore with the professor, as you see here. Here is our technical team, the execution, site execution, and the aftermarket maintenance team, which I talked about, who are all our on-roll resources. And here are the financial institutions and banks who helps all our customers in funding their captive CapEx solar projects, IREDA and SIDBI being prominent among them. So a snapshot of our technology adopters, where you see all the major names from steel, food and beverages, automobile, and warehousing and packaging segment. Even the engineering industries like RR Cable, Texas Instruments, the steel industry like ArcelorMittal, Man Steel, the pipes industries like Ashirvad Pipes, Durgapur, the high-tech pipes, Pan-India plants are solarized by us. And food and beverages like Baskin-Robbins, Bector Foods are all solarized by Becker, as you can see. So Man Steel, one of the largest steel pipes manufacturer, has solarized all its pan-India plant with our CAPEX on-site solar model. And the industry events that we have sponsored, one among the recent ones is the Business Today event held in Pune, where all the prominent personalities from the corporate world were present for the Best CEO Awards. Coming to technology area number 3 is the automation that we have introduced,
You have
developed
2
and
minutes.
manufactured
2 minutes.
in-house. So could you play the video number 2, please? So this is basically the cordless solar powered robotic wiper. As you see, it's the steel factory that I talked about, having one of the highest environmental dust levels. So it's very essential to keep the solar plant free from any dust and contamination to get the maximum generation out of it for solar sunlight penetration. And this automation helps you eliminate the manpower cost, time and effort, and water required for manual cleaning. This is called cordless because it's powered by solar energy itself. As you can see, the moving frame is integrated with solar panels, which propel the device by charging up the lithium-ion batteries. So this is the rooftop solar installation. Could you play the video number 3, please? This is another video where you will see the ground-mounted solar plant that we have done in Madhya Pradesh, which is over a 2 megawatt plant. And the robotic wiper is again doing the cleaning round to eliminate the dust settling on the solar plant, which is a major recurring cost and pain area, labor-intensive recurring cost to keep the solar plants clean. So this is the automation, and this is manufactured in-house at our Indore factory, the cordless robotic wiper. Thank you. Please go back to the PPT. So here is the manual versus the robotic cleaning comparative. As you can see, you save water, you save time, you save manpower cost. And this is the cleaning element, which is a microfiber cloth, which does the cleaning through solar powered. And this is not limited. You can have any frequency of cleaning daily, weekly, or even twice a week. Coming to the other aspects, the key differentiators, what we have over and above the other solar players, the 25 years of warranty on the complete hardware helps you eliminate any recurring CapEx cost for replacement of inverters or any accessories. The robotic cleaners, which helps you eliminate the recurring cost of labor. The 10 years of technical AMC, which we present along with our CapEx offer. And of course, the puncture-free technology with load on your roof less than 13 kg per square meter to take care of the health of your factory building in the long run. And this is the solar eye technique, which is used by us to do the power prediction for a period of 25 years with an accuracy of over 97% with all the parameters like the geographical coordinates, the seasonal variations, the environmental dust factors, roof angle, roof direction, and even the grid power fluctuations and local dust levels taken into account, wherein you can see the prediction coming on a 12-month basis with the maximum generation coming in the summer months as anticipated because of the seasonal reasons. So I will end my presentation with a video of our completely integrated. You can play the video number 4, which highlights the solar technology. This is one of our installations, and you can see the robotic cleaners integrated with the rooftop installations here, which move across your roof, cleaning the solar plant without you spending a penny on manual cleaning on day-to-day basis. Thank you so much.
Any question, please? Any questions from the audience?
Yes, please. Yeah, it's the TopCon panel. We have complete range of solar PV modules, starting from the mono PERC to TopCon to HJT. The highest efficiency, best in class, is the 23% conversion efficiency, basically from sunlight to electrical power. That is the TopCon module, 23%.
27% efficiencies are also coming. 27 per up to.
Yeah, it's an evolving technology, right? So currently it is monocrystalline TopCon, which is a very, very stable and proven technology, which we have also installed in Kolkata in Megaflex and Ashirvad pipes in Durgapur, the nearest ones. And it is going to remain so for next half a decade, unless the next generation of PV modules come in and prove themselves.
Okay, thanks.
Yes, please.
Hi, I'm Rahul Vijay from Axis
Hi,
India.
Rahul.
My question to you is that what is the raw material used in that robotic cleaning? Is it water? If it is a water or air, don't you think that is a waste of water because that is a long panel which has to be cleaned? Thank you.
I think, Rahul, you missed the point. The robotic cleaner is basically a dry cleaning technique. It saves your manpower cost, it saves your time and effort of supervision, and it definitely saves a lot of water. So it's a dry cleaning technique, and the microfiber cloth that you saw is basically the consumable, the cleaning element, which needs to be replaced quarterly basis, which is done by our site execution team for all our installations.
So you also take installation AMC also, right?
Right.
Right.
For 10 years, it is free. For the first
10 years it is
for the
free?
first 10 years from our installations, it is included in the capex price.
Okay, thank you. That's the answer.
Just to give you a ballpark estimate, a 1 megawatt of installation, the investment is around 2.4 to 2.5 CR. Yes. Any other questions?
Thank you.
Or
Thank you so much.
I now hand over it to the next.
Thank you so much.
Okay.
In fact, 1 hour of sunlight, it gives you the power for 1 year's consumption of the world. So that's the potential of solar power. So without taking into more details of it, let me call upon Narasimhan Arya Somayagulu, General Manager, Technical Sales, Hot Rolling Danieli India Limited. And his topic is Danieli Universal Endless Hot Rolled Coils to the next level using full grain technologies. The floor is yours. And you can speak up to 20 minutes. I think organizers have decided to give all of the people 20 minutes. Thank you.
Order to spread that. Okay. Still few minutes before the noon, so very good morning to ladies and gentlemen. I'm Narasimhan from Danieli India Limited. And before I proceed, I take a moment to wish Mr. Mukherjee a very speedy recovery. At the same time, I would like to acknowledge and appreciate some of the earlier speakers, Mr. Sharma for his global perspective and for setting the contest yesterday, Mr. Panda of JSW, Mr. Kumra Sain, Mr. Ratna Prasad, Mr. Pugazinti sir, and previous speakers who spoke very wonderful about the green steel decarbonization aspects. So while I'll speak something different than what people have spoken, this is my privilege here since I will speak about the hot rolled coils. So as you can see on the screen, my topic for the day is hot rolled coils to the next level using full green technologies, which we call it as Danieli Universal Endless.
So since I have this liberty of 20 minutes, I will split my presentation to 6 topics. And to start with introduction, this is the green steel taxonomy for India. And India is the only country and the first country in the world which has so discreetly distinguished what is green steel by dividing into various slabs, 5-star, 4-star, and 3-star. And if you look at it, it doesn't speak about, it's too small to read, okay. It speaks about, for instance, 5-star is 1.6 tons of CO2 emitted per total finished steel, TFS, and not TCS, total crude steel. That's a big difference. We are talking of emissions for total finished steel. That means a cold rolled coil or a coated coil, what is the total CO2 that it has emitted while it had its journey from soil to the final end coil. And here, as the scope of emission is divided into scope 1, scope 2, and scope 3. We all know scope 1 relates to the direct emission coming from the facility or the manufacturing unit that you have. Scope 2 is the indirect one coming from the electricity or the utilities that you utilize. And scope 3 is still far away. It's about the indirect in terms of transportation or various sources. I think the government of India has now spoken about scope 1 and scope 2 with a limited scope 3. Limited scope 3, why? They have included agglomeration like pelletization and sinter plant. And as a OEM supplier, Danieli, I can speak about the scope 1 emissions through the rolling technology that we foresee. As many people here are from the steel industry, we all know that in an integrated steel plant, the major contributor of CO2 is in the iron and the steel making zone, while the rolling mills have the leverage of being little cleaner. But still, in case of rolling, when we talk of hot rolling or cold rolling, there is a concept of recrystallization temperature. So anything above is called hot rolling and below is called cold rolling. So there are avenues where certain thermal energy and electrical energy have to be input in order to create a solid hot rolled coil. So there we come here, Danieli concept for direct slab casting and rolling. Previously, there were a concept of thin slab casting and rolling because the slab that was cast was around 40 mm, 50 mm, 60 mm, 70 mm, but no more it's that. And we have changed this by calling it as a direct concept for direct slab casting and rolling because with Danieli technology, we have proven slab thicknesses up to 150 and 160 mm. It's no more thin. It's, you can say, a good amount, substantial amount of thickness. And what is the advantage? We all know that the thicker the slab, the more is the reduction, and the thinner you go, you get the right mechanical properties. So something which was eluding the thin slab casting rolling concept. But with Danieli Universal Endless, with our technology of caster, we are able to produce slab thicknesses up to 150 and 160 mm. We have proven 160 mm in our recent installation in Yukon. So imagine you are having 160 mm slab thickness and you're going down to 0.8 mm. Or say 2 mm, 2.5 mm. So you can understand the amount of reduction that has gone through, and more is the reduction, the more is your mechanical properties, giving you a standard quality. This is a typical layout of Danieli QSP Duet. So we call it Duet Danieli Universal Endless. And as you can see here, we are talking of the caster till the down coiler here, the slab caster followed by the tunnel furnace. In front of the tunnel furnace is a pendulum shear, the hot strip mills, the laminar cooling, and the down coiler. What makes us the difference is that our mills are split, the rougher and the finisher. And what is the advantage of it? I will try to speak in the next slides. As you can also see here, we mentioned CTC, that is coil to coil, which is something like a batch mode, one slab into one coil. There is in between a semi-endless and then the endless. Like endless is also a concept which is known to most of the people here, that in case of endless, there is no particular division of a slab. It is cast continuously and the coils are made. But then how is the difference between having 3 modes? Imagine a car, you have eco mode, you have a powerful mode, or you have a cruise mode. So based on the road that you drive, you can change the mode in order to have the best suitable output of your car. It is similar, like coil to coil has certain advantages, the semi-endless and endless mode. Let me give you a point like semi-endless. When do you prefer a semi-endless? For instance, you would like to roll silicon steel or ultra low carbon steel, which has the limitations of having slow casting speed, but at the same time has to have a higher finishing mill exit temperature, which are contradicting statements. So you have a slow casting speed from the caster, but you need to have a higher temperature at the FM exit. So that's where these induction heaters in between will help you. And so a semi-endless will give you a better feature. Now I'll explain to you what these CTC, semi-endless and endless are. So this is a coil to coil in which you can see that something is traveling here. And then one slab becomes one coil. And the partition is by here, the pendulum shear. This is something very typical of what we have seen in thin slab casting and rolling of some of the plants in India. Now comes the difference, the second one, the semi-endless. In case of semi-endless, what we do is one slab is equal to the complete length of the tunnel furnace. You see, now the partition takes place. And this longer slab can be further made into baby coils of say 5 or 6. The division takes place at a high speed shear. The semi-endless is something which is having the benefits of the coil to coil and also has the benefits of the endless one. As I mentioned, in case you want to roll the silicon steel NGO, then the semi-endless one will give you all the best features of it. Now this is the endless mode. So there are technologies available in the market which have a purely coil to coil or a purely endless, while what we are offering is a plan which can work on all 3 modes, and you can choose between coil to coil, semi-endless and endless. Endless is something very important when you go for ultra thin gauges of talking 0.8 mm or 1 mm of low carbon. With the tight geometrical tolerances, you can go for endless. While you're talking of silicon steel or you're talking of ultra low carbon exposed grades, then you can switch to the semi-endless one. And then you're talking of API, you can go to CTC, coil to coil mode. Now, what is the challenge of endless mode? The challenge of endless mode is that it is little energy conservation, and it takes a lot of energy in terms of induction heaters. Why? Because of the slow casting speed, which is driven by the caster. And so you need to have some temperature here. And so it is intensive. But at the same time, you are able to do it because you get a premium from your customer of, say, you're selling 0.8 mm hot roll coil with a flatness and with the thickness tolerances of around 16 micron, for instance. So this is in brief about the same layout with you have a tunnel furnace with shuttle, a 3-point descaling system, and you can see here the range is from 0.7 to 25.4 mm. I'll quickly run through this video, which is our plant in Yukon in China. Now, what makes a difference is it is a direct casting and rolling plant where we have cast 160 mm slab also, 145 mm slab also, and the mill has produced 0.8 mm coil. The mill has produced 25.4 mm coil also. Here you can see, okay, so I wanted to pause at a particular movement which is of interest, though it's not related to our technology, but still it would be of interest to the people since we are talking of green steel. So you can see this hood, which is over the ladle. And this hood is something we have seen in every steel plant in China. Though I would say this is not our technology, but then it is coming from someone who is into suction hoods, and they put over the casting platform, the ladles. This is the casting platform, and you can see this hood nicely built, and it absorbs all the fumes. So this is something relevant to a particular topic of today. This is something can also be thought of for the steel plants. It doesn't mean it's a direct casting rolling or a conventional slab caster. So these are the visuals of our plant in Yukon. And the beauty of Yukon is this is a 4.6 million tons per annum plant. Typically, thin slab casters are around 2.5 or 3 million tons per annum. But this one is 4.6 million tons per annum. And it is the world's highest throughput plant working on 2 slab casters. Initially, the customer wanted to put up a hot strip mill, but then when we tried to convince him and we saw the benefits that he can have a range of 0.8 to 25.4 mm, and there is no limitation in any of the grades, then this is the beauty which has been 4.6 million tons per annum. So that's what we're talking about. Now, I have stressed this point again, 4.6 million tons per annum. Now, how does this affect to the decarbonization topic that we are talking of, which I'll explain in the next slides. I will like to skip this quickly. Okay, this is again what I said. It is a 4.6 million tons per annum hot rolled coil Yukon. So now, as Danieli, we say that decarbonization or green steel, if this is the vision for you, then we say direct rolling is the only one which can give you competitive and green hot rolled coils. Here I mention any grade. You can talk of also the IF, interstitial free exposed grades. I would like to speak about this. This was until now done conventionally through the slab casters because it needs to do a scarfing. Interstitial free and auto exposed grades, the slabs after they are cast had to be clean on the surface. But in case of QSPDUA, we have a provision of also getting these slabs scarfed before they enter the rolling mill, and thereby it's possible to have interstitial free steel also. ES electrical steel, API up to X80. And how is possible? I mentioned you like, for instance, our rougher and finishing stands are separate. So in between the rougher and finishing stands, we have a transfer bar cooling. So you can bring the temperature below the recrystallization, and that promotes the thermomechanical rolling. Electrical steel, as I mentioned, there are induction heaters before the finishing mill. So you can go with higher input temperature to have around 920 degrees centigrade, which is required at the exit of FM. So practically you can have all the grades from one single mill. Until now, the policy was like, you would like to have low carbon steel, then let's put up a TSCR. You would like to have a conventional grades API, put up a hot strip mill. So for one, you mean you are putting up 2 rolling mills for different uses, and that is where it can be curbed. This is about the 3 operating modes that I mentioned, and I also had briefed about the advantages each mode has. Then over the thickness, 0.7 to 25.4 mm, thinner to the max. And these are few numbers like the OPEX benefit, what you can get is around 50 euro per ton. I would not like to speak more about it, but then since it requires a little bit more elaboration. But what you can see is that the benefit of 3 modes gives you a certain amount of savings or efficiency in your operations. The thermomechanical rolling that I mentioned, and the flexibility of reducing the width on line. And also the tunnel furnace gives you a benefit that you need not have to stop your mill for doing the roll change. So this way, you will have a substantial amount of euros per ton saving. And when you have euros per saving, you are naturally being competitive in the market. These are some of the references. You can see a number of them. And one, I would like to mention SSAB Luleå. We all know SSAB is a pioneer in steel industry, and they have recently declared about their green steel investment in Luleå. And they also have hybrid technology. One of the speakers spoke about it, the hybrid and the LKAB kind of iron making. So Danieli has been chosen to prepare to modify the steel making and the rolling mills for a $1 billion. And this is a plant where all these technologies that I mentioned are being implemented, including the tunnel furnace being charged by electricity. So it's an electrical tunnel furnace, and this is our evolution. I skipped the slide. Now the green concept. This is of importance for the day. And I would like to spend a few moments over here. So summarizing what I said about our technology, the various features it has in different modes, and the flexibility of rolling any grade, the flexibility of producing 0.7 mm to 25.4 mm thickness. Now, how is it going to help you in decarbonization? So the QSPDUA will help realize your vision of producing steel with a lower carbon footprint. Now, how? Lower footprint. This is a typical layout. What you can see is from the caster till the down coiler, it is around 380 meters. A typical hot strip mill, conventional semi-continuous one, will require around 400 meters. So this is where one of the advantages comes. The layout is very small, so the carbon footprint is less. Then the lower thermal energy as the input. Now, as I mentioned, the tunnel furnace, the input of the slabs at the tunnel furnace is around 900 to 1000 already. And then the exit temperature has to be maintained at 1150 to 1180. So you're talking of only a delta of 200 degrees centigrades. On the contrary, if you talk of conventional hot strip mill, the reheating furnaces will have a delta of say 45 degree, that is ambient, to 1200 degrees centigrade. So here, in case of a tunnel furnace, which is the benefit of direct slab casting, there is less amount of thermal energy required. Now, this tunnel furnace can be gas-based. You can have mixed gas, you can have natural gas, and all we know that the burners which are suitable for natural gas can also be adapted in future for hydrogen. You can also replace the gas-based burners with electrical heaters and induction heaters also. And this is something which we are already providing to SSAB Luleå. The second one, the third, number 4, wide range of grades for a single mill, avoiding putting up multiple rolling mills. It has been a norm that most of the steel plants in India, the big ones, they put up multiple rolling mills, dedicating one rolling mill for a few grades and another rolling mill for another kind of a typical grades. But as I mentioned to you earlier, there is no limitation of any kind of a grade or any kind of thickness. So you can put one mill, and you talk of capacity. The natural flair of Indian steel makers is to have rolling mills in multiples of 4 or 5 million. This is something that we have seen for the last 10, 15 years. And that is one of the reasons why blast furnaces are chosen, in my opinion.
Sir, only 25 minutes you have taken.
Okay, fine. I'll be quick, another 2 to 3 minutes. So since the flair is normally to have 4 or 5 million kind of capex investment, everywhere you will see the big companies that put up steel plants in multiples of 4 or 5 backed by blast furnace. So there was a limitation of adopting this kind of direct slab casting and rolling. But then when we have this technology of producing 4 million tons, it brings to your vision. Okay, this is the mold that helps us to have any kind of grade to be rolled. Now, this one is interesting. The tunnel furnace is having induction heaters in the entry and exit. So you can eliminate any kind of gas. Then typically a conventional rolling mill will have 5 to 7 passes. But here you can have the 5 passes and still get the right surface quality. So automatically your electrical consumptions are less. Now, I would like to stress on this topic, which could be of interesting here, but in less than 2 minutes for sure. The power of substitution. One of the prime reasons of having a cold drilling mill is to have, to reduce the thickness. One of the prime objective of the cold rolling mill is to reduce the thickness of the hot rolled coil to a thickness range of say 1.5 to 5 mm as a hot rolled coil, and then reduce it to 0.1 to 2.5. That is one of the prime reason why a cold rolling mill is established. But then if I say that I can deliver you hot rolled coils of up to 0.7 mm, so 0.7 to 1.5 was a range which was untouched by the conventional hot strip mills, let's say 2 mm. Up to 2 mm was something which was coming from conventional hot strip mills. But now with 0.7 to 2 mm, it is very much possible from the hot rolled coil. So naturally, your reductions on the cold rolling mill can be avoided. And then there are certain grades. So you can see, I try to blink the cold rolling mill. And there are certain grades of steel. Let's say where the requirement of cold roll was only to have a thinner gauge, but little less stringent surface requirements can be directly replaced by the hot rolled coil. Some of the applications which have been already proven in one of our Chinese plant in Shougang is this particular grade, SPHC and SPHT for the pipes and tubes. So they were directly replaced by the hot rolled coils. Some of the structural parts, some of the galvanized parts, and some of the forming parts, and also this DP780. So we were able to produce, give a hot rolled coil to a yield strength of 780, and also the right surface finish, the flatness, which could directly go into the automated structure part. So what I would like to highlight here is that the hot rolled coils were naturally going to cold roll mills for a further reduction, and then they were being coated or to get into certain kind of requirement. But then if the requirement of thinner gauge is fulfilled by the hot roll coils, it can avoid certain amount of reductions in the cold rolling mill, and thereby you save some energy. And at the end, when you talk of carbon emissions per ton of finished steel, you are reducing it. So that's it from my side. So I summarize saying that Danieli Universal Endless is one of the Danieli competitive, intelligent green metal plant with zero CO2 emissions, with all the reasons that I have explained until now. Thank you.
Thank you, sir. You have taken only half an hour. So I would request the next speakers to stick to the 20 minutes time. No more questions. Questions will be discussed after the session is over. Okay, so next speaker is Ashok Vishwakarma, VP Quality Assurance, APL Apollo Building Products Limited. Step to convert steel into a healthy and more sustainable product.
Good morning. In fact, it is good afternoon. Thanks to the organizer, Steel and Metallurgy, and all the dignitaries present here. So I will touch one more very, very important factor, which in our Alu-Zinc line, healthy and more sustainable product. So this is the overview of our company based at Raipur. So this is the panoramic view. We have almost 600 acres of land, and we have 2 flat products unit and 2 tubular products. So I will not go in details, already covered by our CEO, Mr. Brajesh Nahar, yesterday. Now, the sample under study was, the thickness was 0.5 mm to 1 mm, and the coating was AZ150, and the steel grade was DX51D as per EN 10346. And then corrosion we did in normal salt spray test with a salt concentration of 5% at 35 degrees Celsius temperature, and we did validation by different like potentiometric polarization or electrochemicals impedance. So some of the this study is some research papers and some done by us. Now the question arises in this Alu-Zinc, why 55% aluminum? So if you go through this curve, you see that when the aluminum content is increasing, so by 55% aluminum, it is reaching the maximum this corrosion resistance capacity. And after that, if we are further increasing this aluminum content, drastically it is decreasing. So that's why 55% is chosen, though there is no eutectic or eutectoid or peritectic or pectotoid reactions taking place in the equilibrium diagram of aluminum or zinc. Now the first thing is that effect of spangle size. So in our study, like 0.5 mm to 4 mm. So 4 mm is the large spangle in case of Alu-Zinc, and 1 mm it is called mini spangles. So what is the impact of a spangle size on the corrosion resistance? So the top left side, this is mini spangle, and the bottom left side, it is the big spangles. In the mid, this is the SCM, that cross section of the coating. On the top, this is mini spangle, and the bottom is large spangle. So here, as Sir Strader told, that zinc is the only element who sacrifices itself. So in this case also, there are basically 2 phases. One is overlays and one is inner, that is a combination of iron, aluminum, zinc and silicon intermetallic compound. So it is very, very important layer, very thin, but very important And just like aluminum plays a role in case of galvanized, it plays the same role in case of alu zinc. Overlays, a combination of there are two phases, like aluminum rich phase is there, that is dendrites, and then interdendritic space, which is mainly zinc rich phase. So by this symmetric diagram on the left side, it is larger spangles, and the right side it is mini spangles. The first corrosion starts on the zinc rich phase, and because it is loose and it is going on, after that the corrosion starts on the aluminum rich phase, which is and it converts the main, that is Zn5CO2OH, into more denser, that is Zn6Al2OH CO2H2O compounds. So it is more denser and uniform. So when the spangle size decreases, you can see on the right side that it has to pass through that crisscross paths to touch upon the steel substrate, or before that intermetallic compounds. So the path length is more and it becomes narrower, so that there is hindrance of the corrosion products progress. By this capacitance impedance loop also, we can see that impedance is basically the combination of reactance and the resistance to the AC current. So in the, as we know that this corrosion process is electrochemicals in nature. So when we are increasing or decreasing, so there is changes in this loop. So by decreasing the spangle size, that bigger one, red color, 1 mm spangle is there, that loop, impedance loop is very, very larger. So what is happening, that oxidation reaction on the anode and the reduction reaction on the cathode, so it is decreasing, because more resistant, it is that AC current which is generated in that wet electrochemical reactions. So lesser or lower that spangle size, it makes more hindrance. Same thing when we go to this potentiodynamic So here also there is on the vertical axis corrosion current is there, and on the horizontal axis corrosion potential is there. So as the spangle size decreases, that it is shifting towards right side. At the same time, the current requirement is also decreasing. So it is also validating that when we are decreasing the spangle size, that resistance to corrosion will be more. Now, another that practical approach, that effect of deformation process, we are using alu zinc products sheet for forming or for drawing applications. So on the left side, it is undeformed steels, undeformed coated products. So if you see this graph, that when the spangle size is less, so more corrosion time is required. So it is touching up to 4,000 hours. And when we are increasing the spangle size, so that corrosion rate is fast, and the lesser time, that is 2,500. So between 1 mm to 4 mm spangle size, when we are increasing, that corrosion rate is fast. And when we are decreasing, it is less. So more corrosion resistance product we are getting. Middle, when we are doing this forming, bending application for roofing or that trapezoidal sheet making for roofing purpose. So here also same thing is happening, though the corrosion rate is more with respect to undeformed states. But here also that lower and smaller spangles giving more corrosion resistance product. On the right side, it is Erickson cupping test for drawing application. Here also same phenomena is happening. So here also we are getting that up to 3,500 hours when we are decreasing the spangle size. Now on the left side, mini spangle is there, so more denser that, and the short path is there. So when the corrosion product is trying to penetrate the steel surface, so due to the denser and the shorter and the narrower path, it will take longer time to reach to the substrate steel. Where right side, large spangle, you can see that the path is wider and longer. Same thing is happening in cupping test also. Here we can see that there are so many hindrances because in the cupping test, three-dimensional deformation is happening in the lengthwise, widthwise, and at the same time in the thickness-wise also. So here also, when we are decreasing the spangle size, smaller, yes, so zigzag paths are there, so it will not move easily to the substrates. Now, the second important is that cooling rate on microstructure size. The top left side, the cooling rate is 1111 degrees Celsius per second. Middle one is 31 degrees Celsius per second, and the right top side 50 degrees Celsius per second. Bottom is the cross section of the in the SCMS analysis. So here also we can see that lots of zigzag narrow paths are there when we are increasing the cooling rate. Means there is very less time to grow the grains which are forming, and when we are decreasing the cooling rate, that small grains are merging and making the grain size larger. This is that bottom left side, you can see that at low cooling rate, there is a straight path, so touching to the intermetallic compound. So very easily, whatever the corrosion is taking place, it is touching to the intermetallic layer, which is the main protective layer. And the right side, when we are increasing the cooling rate, so the spangle size decreases and so many zigzag passages are there. So it will not easily touch to the base metal. Why 1.5% silicon is there? So we can see that here 1.0% up to 1.8% silicon. So up to 1.5% silicon, there is that cooling rate up to 20 degree or 25 degrees Celsius per second, and the secondary dendritic arm spacing, there is that slope is very high. After that, when we are increasing the silicon content, that slope is decreasing. So that's why in 55%, 43.5% zinc and 1.5% silicon is chosen. Now this is the that aluminum rich, zinc rich, and that eutectic aluminum zinc silicon eutectic blocky. What are the in the aluminum rich? Almost 80% aluminum is there and 20% zinc is there. In the zinc rich phase, it is almost 80% zinc is there, and something around 10 to 20% is aluminum is there. In the Aluminum, zinc, silicon, eutectic, 55% silicon is there, and the rest aluminum and zinc are present. This is our summary of our actual test done at our company laboratories. As per the standards, when we are using AZ-150, that corrosion resistance, that formation of red rust, 1,000 hours, we are getting more than 1,300. So that was the beginning of our study, why it is happening. So that was the beginning. So there, it is proving our actual. So we have two laboratories independent from each others, and both places we got the same results. Even in humidity test, we are getting more than 2,000 hours that red rust. Yeah, still it is going on. Now this is the table as per ISO 9223. The reference is there that what is the corrosion rate of the normal steels, and the yellow colors, the corrosion rate of zinc is shown. So that zinc is almost 20 to 25 times more corrosion resistant to the normal steels. So that's why it is protecting the base metal and enhancing the life of the structure. And there are, on the second column, you can see that there are 5 types of corrosive atmosphere, C1 to C5, which is the highest corrosive atmospheres. And this is the table, comparison table of that base metal, which is steel, that yellow galvanized. So it is giving 20 to 25 times more life with respect to the normal steels. So thus enhancing its the life. Now, as I earlier explained through my earlier slides, that in case of alu zinc, it is 2 to 4 times more corrosion resistance to the normal galvanized. So further life enhancement is there. Now, by going through that, this on the top blue color table is there. So we have compared with the corrosivity in different atmosphere. Like the base is C1, which is the dry and rural areas, and C5 is the highly marine. So 7 times it is actually it is very yeah. So 7 times up to 84 times more corrosion rate is there. And this blue color graph is for normal steels. Then there is zinc, and then below that it is alu zinc. Now, whatever the paint we are using, irrespective of it is RMP, SMP, SDP, irrespective of the paint quality, we have reached that rust-free life more than 1,000 hours. So as per our paint supplier, like Umesh Vishwakarma is there. So he is our supplier. So irrespective of different type of paints, we have achieved by controlling our that is spangle size and increasing the life of the alu zinc, over which we are doing color coating. So that's all from my side.
Big round of applause for Vishwakarma ji. Thank you. Now I think we have with us Srinivasan Krishnamurthy, Managing Director, Pole Rich India. May I call upon Srinivasan ji to be in the dais? Okay, please be seated. I will be calling you after the course of time. The next speaker will be Kranti Chitithoti, and with him Pramod Almore is there, but I call upon Kranti Chitithoti. Kluber Lubrication Private Limited, and he will be speaking on accelerating the global transition to green steel with energy efficient lubricant. Sir, time is 20 minutes only.
Good afternoon, everybody. Before I begin, I would like to acknowledge the great conference that's going on here. It's really insightful to see so many people coming together to create a sustainable future in the steel industry. And this presentation that we are doing here is primarily also a small step to actively participate in this journey. Here I have with me Pramod Almore, who is heading the steel industry, steel sector for India, and I take care of the sustainability part of it. So steel being a kind of a hard to abate industry in terms of emissions, we work very closely to ensure that we provide the best solutions for the industry. So as you can see from the topic that we have chosen, there is a transition to green steel, and that's what we're discussing. And here we want to understand that while we transition, there will be a lot of emissions for sure that we all know. But there will also be a lot of costs. And what we want to present is a business case where you will, of course, reduce emissions, but you'll also be using a most cost-effective solution. And here we are talking about energy-efficient lubricants. We represent Kluber Lubrication, and we are a specialty lubricant manufacturer. And we have been working in this area to partner with the steel industry actively to be able to control emissions, but also reduce the total cost of ownership of your operations. So on the first slide, as you can see bottom, there are 4 circles there. They are basically awards we have been winning in the space of ESG. So for us, sustainability is not just environment, but also about how we run our organization. And all of us know that ESG is a big term, environment, social, and governance. And in India, the government has also mandated the listed companies to go for BRSR, Business Responsibility and Sustainability Reporting, and which actually mandates that we don't just look at the emissions aspect, energy emissions, wastewater, but also look at the way we handle our employees, how we train them, and also how we have the governance framework in place to be able to manage these things. So we have been winning this award for the last 4 years consecutively. And this is actually a matter of pride for us because we are one of the few companies who have been consistent in consistently disclosing our measurement and reporting of the way we manufacture on a scope 1, scope 2 basis, but also the way we innovate across the value chain. So this is what I'm going to cover in the next 15 minutes, okay? So here I would like to highlight and go into the details of the award itself. This is awarded by one of the leading ESG agencies in the world, which is EcoVadis. And what they look at is, as you can see here, they don't just look at the environment aspect of it. They also look at the way the human rights are protected within the organization. They look at the diversity. They look at the way we procure our raw materials and the code of conduct and the ethics that are followed in the organization. So for us, sustainability is just, it's actually slightly larger in terms of ensuring that the government, the organization itself is sustainable, because while we want to transition to green steel, we also want to make sure that the economic viability of the transition is protected. And that's what makes a sustainable organization as such. So here I would like to highlight one thing for which we have been recognized, which is that the carbon management category, we had been in the advanced stage, which means the way we manufacture our lubricants is in a very, very green way. And when you procure from us, what you're looking at is a supplier who has worked on both the sides of the value chain. Both our suppliers and our customers who are using a product are actually going green as well. So here are some 12 aspects that I would like to highlight and what we are proud of. Again, touching upon the ESG, or in India, the BRSR aspect of it. So we have been recognized for being actively disclosing our carbon footprints, but also working in the value chain itself, innovating across the industry together with our vendors as well as our customers to whom we supply. So I will, of course, cover some of these aspects in our slides, but one of the things that I want to highlight is in the bottom rows there. You will see that there is a high focus on diversity in the organization. We want to have diverse working groups in the management. We also want to have a proper corruption-free organization, which actually follows certain code of conduct in our interactions as well. So for us, I want to reiterate the fact that the energy, the environment, the social and governance is very, very important for us. And what you can also see is that not just scope 1 and scope 2, we are actively focusing on the scope 3 aspect of things, because scope 3 is it's the toughest aspect of the whole measurement process, as some of you might know. And this is important for us as well, because innovating in the value chain is very, very important to build a sustainable ecosystem in the steel industry. So today's topic, of course, we have been all discussing about various technologies, the DFI, DRI, EAF, and all that. But today I want to focus on specifically the lubrication aspect of it, which is energy efficient, and how using and shifting to energy efficient lubricants can help you not just save energy, but also reduce your carbon, the cost of operations. We all know the challenges that are faced in the steel industry. We have a lot of emissions. We actually use a lot of electricity. And in the quest to reduce our carbon footprint, we are also using a lot of electricity. So here, we are proposing some kind of a methodology where you can move to an energy efficient way of using lubricants, but also reducing your total costs in the process. And this is a strategic priority for all of us here, to be able to run our operations while we are transitioning to green steel. So I want to highlight that sustainability is not just what you use, but for us, both our footprint and your footprint, the ones whom we are supplying to, is equally important. So we have 6 pillars of sustainability. Of course, we all know energy and emissions, but we also have waste, water, and the way we source our materials, and the way we protect the safety and the health of the users. So these 6 pillars are important for us, even when we manufacture how we source and how we transport the lubricants is very, very important for us, as you can see here. Similarly, the way you as users are using lubricants, they must be compliant in terms of the way you're following the emissions, but also the way you dispose, right? So the life cycle assessment is already done for all the lubricants that we manufacture. Some of the previous speakers were mentioning about being able to present the carbon dioxide footprint for every lubricant that we manufacture. So if you ask us what is the carbon dioxide that is emitted per kg of lubricant that we are supplying to you, we can be very precise in telling you what is the number. So these are some things that we are very, very proud to actually be able to give out to all the users. And therefore, it's important that all the 6 pillars are actually taken care of. So here, I would like to highlight one more thing which we are very proud about. This is the case where I was highlighting about the innovation in the value chain. So we had been asked, or we had been working with a leading steel major in India who had issues in the continuous casting application. And there we had developed a product which can reduce the clogging issues that they were facing. And with a lot of trials and errors, finally, we had been able to come up with a product which is now used in all the casters in India. And it's something that we are proud of. I'll tell you why. Usually, as a German company, we are dependent on our European counterparts to give us technology, and we apply it in India. This is one case where this is a product that was developed in our Mysore plant, tested in an Indian steel maker. And finally, this is a product that is now successful, and this is now being used in all the global steel plants. And therefore, this is a matter of pride. This is made in Bharat. It has also a BH in the product naming. And therefore, we are very, very happy to continue to work with all the steel manufacturers in this space to innovate and provide sustainable options. I also want to highlight that, we do a lot of energy measurements for our lubricants that we supply. Now, energy measurement is not so easy because, the way the energy can change because of so many variables or complex. It's not just 5 and 10 variables that are impacting energy consumption, but you have almost up to 30 variables that need to be collected and measured to be able to see the difference in the energy that you save using lubricants. And here we have a process, very scientifically a followed process, which is approved and certified, where we have been able to very systematically measure and also demonstrate the energy savings that you can achieve with shifting to energy efficient lubricants. And let me move on to the various references that we already have by conducting these projects. We have across the world, across industries. As a lubricant manufacturer, we are where the friction is. So every moving part in the machine moves and also leads to wear and tear. Our job is to reduce friction as much as it can. And therefore, for me, I go to various industry conferences, not just steel, cement, but also across industries. And therefore, we get an idea of the various requirements and demands in the market. And everybody is talking sustainability. And of course, steel is one which is a high priority for us because this is where the emissions are very high. And we want to really partner and help you in meeting your sustainability goals as well. So we had already conducted a lot of projects across industries and also specifically focusing on steel. Here, this conference primarily focuses on the flat and coated products. And so I want to highlight that we had been also mastering working in the big, large gearboxes with huge amount of some capacities. And here I'm mentioning some of the cases here. We had cases in Brazil, India, and also different segments you can see in wind and chemicals as well. And I want to focus for this session on the first case there, which is the cold rolling mill in ArcelorMittal, Brazil, and where we have been able to save up to 4% of savings, and this is an important achievement for us because this is something that you can also implement at your sites. And the results of this cold rolling mill energy efficiency project is here. I want to highlight that this, the kilowatt hour per ton that we reduced is something that you could all have a look at. It's actually something that is implementable with very, very low effort, but also with quick returns. And I'm talking about returns less than 1 year. So these are, I'm just going to next 4 or 5 slides. What I'm going to show you is the kind of rigor with which we work, wherein we calculate and look at the various parameters that affect the energy consumption in a rolling mill, and being able to really identify and calculate the energy saved before and after you switch to an energy efficient lubricant. So here is just glimpses of how we measure the mathematical model that goes into it when you use a mineral oil. And then you also do a analysis before and after in terms of the parameters and a change in parameters when you do the project. And here we finally also be able to show the differences when you shift from a conventional mineral oil to an energy efficient lubricant. I want to just take a pause here in case some of you are not aware of generally about lubricants itself, that lubricants work on friction, and the coefficient of friction is very, very important. So when two moving parts are running together, you need a lubricant which can bear the loads, which can also bear the speeds, also the temperatures, right? So when you actually measured across the different categories of oils, we can see that a conventional mineral oil would have a certain level of coefficient friction. But when you shift to a MPAO, the metallocene polyalpha olefin, and the PG, the polyglycol gear oils, you'll see a significant reduction in the coefficient of friction. What does it mean? When you have less friction, you also produce less heat, right, and less resistance in general. So for the same amount of energy that you generate, you need lesser energy input, and therefore you have a smoother operations of a machine and a longer life. And that is the basic chemistry that goes behind every lubricant. And what we have been perfecting over the years is being able to work on the chemistry of it, develop formulations in the industry. As we said, we work with very closely with the steel manufacturers to collaborate and come up with some sustainable solutions as well, right? So that's the kind of basic thing I want to highlight, that this is what's the reason for being able to save energy. Now, I want to also now go into the numbers here, because yesterday and today we have been discussing about the fact that we can transition to green steel, but the costs are almost prohibitive. Now, I want to present a case where the costs may be high initially, but within 1 year, the investments will be reaped, which means you can see the results within 1 year. The payback is less than 1 year. And here we present a case where, depending on the installed power capacity of a gearbox and the possible energy savings, you can see the amount of money that you can save and the electricity that you can save in 1 year. So this, I believe, is our most important slide, where with minimal changes, there is no change of design, there is no change of any other process stoppages. You just have to shift from a mineral conventional oil to a energy efficient oil, and you can immediately see the reduction in carbon emissions, and also reduce, get the results in less than 1 year.
Sir, you need to complete. Already 25 minutes.
Yeah, I'm almost done. Thank you. So what I want to also highlight that there's a study that was done by the University of Florence in Italy, where they looked at various measures that are applied, energy efficiency measures, and the kind of relative investments and the benefits that you get in 1 year. And you can see the relative, you have various technologies that we have been discussing about. When you shift from a conventional oil to an energy efficient oil, the investments and the savings are relatively faster. And therefore, this is a compelling case for all of us to immediately look at it as an opportunity for us to save energy and also reduce costs. Also, on the same study, we have also found out that the cost effectiveness of shifting from a conventional to energy efficient oil is the highest in terms of the kilowatt hour per euro that you invest into this kind of initiative. And therefore, this is a very interesting and significant saving as well as such. This also is same that we don't have enough of projects, and therefore I encourage all of you to look at energy efficient lubricants as a saving in terms of energy as well as costs. Finally, I also want to tell you that we don't just invest in, the projects, but we also help train how to handle, store, and also manage your energy needs within your organization. So therefore, we have a lot of specific support from Kluber Lubrication in terms of energy efficiency projects. We have been doing these projects for many years, and we have almost 500 cases like that, and we'll be able to help you achieve your sustainability goals. Finally, just one more slide I have. We have been working with a lot of end users here. All of them are known to all of us here. And the OEMs here, we've been recognized in the industry, both domestically and internationally, that we have been working in the area of energy efficiency and sustainability. And this is what we take pride in. And what we believe is that this is a big opportunity for the steel industry. With least amount of effort and implementation, you can actually get the benefits within less than 1 year, right? So I would just want to end here with saying that this is a great opportunity, usually overlooked and underestimated. But the moment you shift from a conventional oil to a energy efficient oil, you're immediately reducing friction, you're cutting down on carbon emissions, you're also able to cut down on the costs. Okay. So with that said, I would just end my presentation and would just invite all of you to connect with us, work with us, because our goal is to innovate across the value chain. We want to work with you and develop sustainable solutions so that we can build a green ecosystem in the steel industry. Thank you very much. And if you have questions, we can take later. Yeah. Thank
Absolutely. Thank you, Mr. Kranti. The next speaker is Umesh Vishwakarma, DGM Sales Marketing, Berger Baker Coating Private Limited, Sustainable Solution in Coil Coating. Sir, time is 20 minutes only.
Okay, thank you. Good afternoon to all of you. We learned during the presentations and all the sessions that 1 ton of steel emits around 2 ton of carbon emissions. So do we really know, I mean, how to simplify the number? So how many trees are required to mitigate the impact of for producing 1 ton of steel in our industry? So definitely we'll find the solution and the number during this presentation. So my name is Umesh Vishwakarma. I represent Berger Baker Coatings Private Limited, one of the leading coil coating manufacturer in India and Baker's Group worldwide. And we are practicing and promoting sustainability in a big way for many, many years. So before I start my presentation, I would like to ask you why we actually need sustainability in coil coating. Is it because of the climate change pressure? Or there is a good demand of green products in the industry? Or do we really want to reduce the VOC level and energy and waste reduction in our industry? Or we would like to align our ESG goals and certifications according to the new law that come in future. So these are all the business goals we talk about. And we as a company, we as an industry doing our bit in this direction. But what is the purpose? What is the purpose of doing the sustainability? What motivates us? So this should be the real purpose of the sustainability. A smile on the face of our kids, on our future generation. This is the purpose that drives us for the sustainability. They are the true KPIs, the ultimate return on investment. When we talk about the sustainability, we talk about the future generation. So let's come to the industry where I'm talking about like coil coating industry. It's a very simple process. I will first talk about the process. It's a base metal, basically made up of the galvanized or gallium that goes into the color coating line, having different processes of pre-treatment and the coating of the paint, then drying, and then coiling. And then you get a beautiful coil in different colors, different textures. But what about the carbon map? When we talk about the color coating line, what is the carbon map? Base metal itself emits around 1.8 ton of carbon dioxide footprint in the environment, and our domain, the paint, it contributes around 0.1 to 0.15 ton of carbon dioxide emission during the production and application on the line. So again, energy is required to cure the paint system. So overall, 1 ton of the color coated steel requires, emit 2 ton of carbon emission in the atmosphere. So let's simplify the question that I asked during my previous. So 1 ton of the color coated steel is emitting 2 ton of carbon emissions. That is approximately 100 trees to offset the carbon emission that is taking place. As you know, 1 tree need to work throughout the year to absorb the carbon emissions of around 20 kg. So the number comes around 100 trees. It looks very simple and very small number, but when we multiply with the amount of production we are doing right now, you will be surprised to see. Right now, we are producing around 4 million ton color-coated steel, which means 400 million trees are required to mitigate the impact the industry is emitting in the atmosphere. So 40 crore trees planting throughout the year, it's a very huge task. It's a very complicated one. So let's have some smart solution. Let's reduce the carbon footprint as well through our processes with the smart decisions. And let's see the sustainability as a promise, not as a cost. So there are few key steps that we can take, and it's readily available in the market. It's not like on the idea stage. There are few steps that we can take very easily in the collaboration form with the steel producers, the coil coaters, the paint suppliers, and the end user to implement very easily in India. We can start with the low carbon materials. It's a very basic thing that we can use the raw materials which are emitting the lesser carbon footprint in the atmosphere. Then we can enhance our energy efficiency. In the previous presentation, we talked about, the gentleman talked about the lubrication and the impact it can create. So we can enhance our energy efficiency. We can adopt clean technologies like UV, EB coatings. Why we need the conventional oven for drying up the paint? We can also shift to the renewable energy for our operations, for our processes. We should also look into to promote the circular economy, to reuse the materials which we are emitting in the atmosphere, how to use it. We can also look to reduce the carbon emission that is taking place because of the transportations and packaging, handling of the material. And ultimately, we should able to measure the impact and how we are reducing it, because we firmly believe that if we can measure it, we can manage it. So first key strategy is, we talk about like base metals. This is not my forte of the steel, but I can talk about the paint. So if we can easily switch from the BOF oven curing to the EAF, it can drastically reduce the carbon emission from 1.5 ton of carbon dioxide emission. It means like 80% saving on carbon footprint. So of course, the paint is a solvent base, where when it emits in the atmosphere, it give a lot of carbon footprint. So we can think about a paint system which is high in weight solid, as well as to make the paint from the materials which are not from the earth derivatives. We can also think about the lowering the VOC metal, and we should also think about to adopt the chrome-free primers instead of the PU primer. We will discuss more about the chrome-free primer later on, because it is not only about the atmosphere impact, it is about the health hazard also. When we see about the sustainability, the easiest way to reduce the energy consumption during the process. Conventionally, a paint system for the coil coating, it requires around 230 degrees Celsius to cure the paint, but we can easily reduce the temperature to 190 degree to 200 degrees Celsius. It saves a lot of energy, almost 25% to 35% lower carbon footprint, and without changing anything in the color coating line. When we think about the sustainability, it is about the scope 3 as well. We have developed a beautiful paint system that is Bakery Thumb. It reduces the temperature, surface temperature of the coated steel by 15 degrees Celsius. It means that a reduction in the energy consumption, in the energy bill as well. So what it do, we have a special pigment in the paint system which reflects a lot of solar energy back to the atmosphere. So it reduces the energy consumption by 25%. In a country like India, where AC is not essential, not a luxury, we can think about this system. This is the innovation at very best. This is the prime example of collaboration as well. Becker's Group collaborated with ArcelorMittal in Europe to produce the first EB, electron beam curing coil coating line, which reduces the carbon footprint very easily by 60%. It is the new innovation. We can think about this technology in India as well. It cures the paint system in milliseconds. Conventionally, it is, the paint system cure by like 25 seconds or 30 seconds in the conventional line, but in millisecond we can get a very good color coated steel. So we can also think about the new projects that may come up of having the EB coating oven. We can also enhance our operations by installing the solar roof, and our Nagpur plant is having 400 kilowatt solar power. So we are using the renewable energy as well to reduce the carbon footprint during our operations. Then we not only use our wastage and the emissions that is taking place in the atmosphere, we also use the material from the outside. We have developed a product that is recycled of the PET bottle and convert into the resin, and basically we use for the making the paint. So we are using the waste of the other industry and making the paint for the coil coating industry. It's a huge revolution, and we have developed this product, we have tested this product, and now it is fully functional and can be used. So that can reduce the carbon footprint in a very drastically way. We can also think about the smart transportation. In a conventional method, we are dispatching materials in 200-liter barrels. We can think about the bulk supply, like 20 KL supply, and smart tank storage as well as handling. So it will definitely, not only reduce the carbon footprint, but as well as the cost that is involved. So when we think about the sustainability, it's not always about the cost. It's about the choice. We can have a smart choice and can have good saving as well. So we do all the innovation, the product development, but how do we measure the sustainability. Because until unless we quantify the number, we don't know, I mean, where we are heading. So to make the right decision about the product, we internally developed our sustainability index that's called Becker Sustainability Index. It's a framework which gives us the direction to improve the product. Of course, there are many other certifications and tools are available like LCA and many things. But to take the right decision and the product improvement, we need our own sustainability index. So how it works, we have two categories. One is the material sustainability, then second is the functional sustainability. So material sustainability is more about the choice of the raw material that we use to produce the paint. It should be more bio-based, less solvent, and less impact on the environment. When we talk about the functionality, it is about the durability of the product. It should last longer so that we cannot, I mean, repainting is required or reinstallation of the seat is required with that. So we broadly categorize the product, the current product category in the 4 reasons: achiever, then concern product, improver. So most of the products that comes in the concern category, we keep changing the formulations, we keep making the formulation better with the better raw material to make it to the achiever level. The product that I talk about, the bakery thumb, which reduces the temperature by 25 degrees Celsius, it falls in the category of achiever because not only it reduces the temperature, but it also having a good life, more than 15 years and 20-year life to sustain. So it's a good product that we can think about. So if I combine a very small steps, these are the only few steps I talk about, but there are a number of steps that is already in place. We can also think about more innovations and product technology. It sum up like we can save around 0.076 carbon footprint. Again, if you remember the number, then it roughly translates into 14 million trees. That is a huge number with very small steps and not required any kind of investment. So I'll discuss about the PU chromated primer and chrome-free primer because it's very important. It's not about the carbon footprint, it's about the health as well. It's not about the two products. We are talking about two choices that we make to make, and the impact is entirely different. PU primer is the chromated hexavalent chrome primer, which is having chrome 6 hexavalent, and which is not good for the health, and it also having an impact of like cancer and skin diseases later on. So we should think about, I mean, not to use the PU primer, and we have readily solution available. It is the chrome-free primer, because we need to think about our worker as well. It not only reduces the carbon footprint during the paint manufacturing, but it also having good impact on the health. So let's please, I would like to take the opportunity to appeal the coil coaters not to use the PU primer and use the chrome-free primer to save the workers who are making the paint, to save the operators who are using the paint for a longer life. Thank you very much.
Thank you. Thank you. It was a wonderful session you have taken. Really an eye-opener for all of us. So next speaker is Srinivasan Krishnamurthy, Managing Director, Paul Rich, India. And he will be speaking on grain steel, reducing carbon footprint in steel production with centrifugal fans. Sir, you will be the last speaker who will be standing between the lunch and the delegates.
Yeah.
So please look into the time.
Sure.
Thank you.
Thank
so
you.
much.
Thank you very much. It is an honor to stand before you, very distinguished delegates, to present about our company. And thanks Nirmalida and his team for giving me an opportunity. So I'm Srinivasan. I'm the Managing Director of Paulrich India Private Limited. So last 2 days have been very intensive, thought-provoking, and Mr. Sharma said like machining and then honing, right? So I'm just coming back to that. So Paulrich has been a German company over 118 years, specializing in high efficiency centrifugal fans. So what am I to talk about in this fan? So typically in steel plants, I've been in the industry for 33 years. Out of that, I spent 15 years in centrifugal fan industry. So I really understand. So what I can present you with confidence is fans are the major consumers of power in any process industry, especially in steel plants. So we are really consuming a lot of power. The fans are prime movers. So we are going to talk about how we are going to add value to produce green steel. What I mean is with lesser carbon footprint. So the agenda is going to be reducing carbon footprint in steel production, and what are the process air technologies involved, what are the challenges, and what are the innovations and trends, practical examples, and a conclusion. So this is a very quick thing. So reducing the carbon footprint, you see, as we all talked about, there's a huge amount of reduction that is required. So basically, we are talking about energy efficient handling of your process and the waste gases. So support for alternative processes, how we support pollution control equipment also has fans to push or pull the gases which goes through the processes. So reducing the carbon footprint, first is energy efficiency. So we are proud to present that with the technologies available with us, we are able to operate fans or design fans with anywhere between 85 to 86% static efficiency, which means we use lower power consumption and reduce the carbon footprint. So we also have a technology called aerofoil blades, which most of you would have heard. So we have honed that one. So we are able to offer aerofoil blades with 86% efficiency, which are mainly used for clean air applications. Because for dusty environment, aerofoil is not recommended because the dust gets choked into the gaps. And then alternative processes, wherever it is, like DRI plants, wherever we use to move air, so we can offer a high efficiency product. So pollution control, this is one of the key areas. So whether we are using electrostatic precipitators or back filters to reduce the pollution, these are essentially uses fans either before the equipment or after the equipment. So we offer our solutions for this. And one of the critical thing in fan is optimizing the airflow. So how do we do that? We have a specialized inlet guide vane control, which reduces the turbulence when the fan is operated so that it saves on the power. So process air technologies, as you can see, fans are used in blast furnaces, direct reduction, de-dusting, pellet plants. Some of the examples are pressure blowers, combustion blowers, sinter plants, pellet plant de-dusting, recirculation fans, and de-dusting fans. So some of the critical things, I will share this presentation. I will not take you through in depth of it. Basically, what we want to present you is whatever happens in the steel industry, we are very much aware of the processes. We are very much aware of how critical it is to design and develop a fan and thereby give you a very high efficient fan. So we are really masters in this. You can trust us, and then we will be able to offer you a very high efficiency, heavy duty fan design. So some of the fan pictures you can see here. So technical requirements, these are some of the critical applications require a gas tight for CO handling CO gas. So we design, we understand the leak proof. So we do with a machined flanges, mechanical seal, so that there is zero leakage. So some of the operating parameters are mainly temperature, pressure, and air volume. So these three defines the selection of the fan with the best efficiency, selection of the best metallurgy, which can be used for a longer time, And the dust concentration plays a very vital role, because if it is going to be more abrasive dust, like what we experience in sinter dust, it's highly abrasive. So we offer the right solution with a wear protection, whether we have to use a chromium carbide or a tungsten carbide. So we have that experience to give you the right product. So efficiency part, as I said, we are stressing, we are able to offer you with about anywhere between 85 to 86% efficiency, thereby straight away reducing your operating power consumption. So we consider all the technical parameters we collect from customers. We do the right selection in terms of aerolic and also the material selection, and offer the right product. So some of the volume parameters, we have a wide range up to 350 meter cube per hour as a small fan, to 19 lakh meter cube per hour in single inlet. Double inlet, it is 38 lakh meter cube per hour. And pressure we can offer up from 360 millibar in single stage and 560 millibar in double stage. So, and in terms of power, up to starting from 1 kilowatt as high as 8,500 kilowatt, we have the range. So you can trust us that we can offer the steel industry a very high efficiency, heavy duty fan, which is going to, reduce your, not only the operating cost and save the environment. So we are in the process of building our manufacturing setup in India. Now we have started our office in Chennai, and we have experienced design and service engineers. In case you require any troubleshooting, in situ balancing, we can offer that services as well. We also undertake energy audit, where we can come and measure the existing fan performance, give you a report professionally, what is the operating efficiency, and we can also suggest you based on a minimum investment, whether by doing a tipping of the impeller, or by changing the impeller, or changing a rotor, or a changing fan. The investment goes in steps, so the returns also goes as per the investment. We can suggest you the right solution. We are building our state-of-the-art plant in Chennai. The location will be decided in another 2 months' time. And once built up in another 8 to 10 months' time, this will be our global manufacturing hub for centrifugal fans. So wherever the fans, we will be supplying from India. So I am really proud to be a part of this growth of Poldridge, where designed by Germany, made in India. Makes me very proud. So with that, I think I conveyed what I want to convey. So this presentation is available for you. So I think we can break for lunch, and if you have any questions, I'm always happy to do that.
Thank you, sir. It was actually 15 minutes, and you were below the time, and that is a really thank you. We should thank him.
Thank you.
But
Thank you.
I would take the liberty of 5 minutes. May I ask you a question?
Yes, please.
So these fans you are using in sinter plant and pellet plants, as you have shown, and you are talking about the wire resistance steels will be used in the fans.
Yeah.
Right. So these plants actually, if you see sinter plant and pellet plants, these are all very abrasive. Dusts will be available. And what about the casings? What about the fans? What kind of life you are predicting now, as of now? And what are the maintenance practices you are going to adopt to bring out a greater life in these fans? Okay, you will be giving a balanced fan, but what is the life?
Yeah.
Life
Exactly.
cycle.
See what happens, right? Very valid questions. See, what happens is the life of a fan depends on the dust characteristics predominantly, how we operate and maintain the fan. For example, let's go one by one. The bearing housings, coupling. So we need to have a periodic maintenance and checking. So when we do that, we can do a preventive maintenance, and then we can increase the life of those components. So when it comes to the impeller, we use, depending on the chemistry of the dust, abrasiveness, and the particle size distribution, we select the right material and the layover of that. So do the hard facing. And we select the tip speed. Basically, tip speed decides when you have a very high tip speed, it wears out very fast. So we have to look into that consideration. And on the casing, we can provide a scroll liner what we call it as a scroll liner. It is again a wear plate which is bolted with a countersunk bolts so that it increases the life. Typically, where we have to arrest is see that you are not, the dust comes, it is not, but periodic maintenance will reduce your sudden downtime. So that is what I would say. And in selecting the hard facing material, whether we have to go in for a tungsten carbide or a chromium carbide, that decides the factor, and mainly the microstructure matters, because many people say that we are also offering a chromium carbide material, tungsten carbide material in paper, but in reality we really do not know. Once after the usage, when the wear comes down, then we do that. So you have to go to the experts who can suggest you the right material. So since we are having 118 years of experience, we have seen everything. So we believe that we have a solid understanding of the process and the knowledge in-house to provide. Have I answered your question, sir?
Yes, actually, partially. What should I tell you is that there are different kind of alloying elements which is being used to reduce the wear abrasion of any kind of metals. You are talking about chromium carbide, you are talking about tungsten carbide. There are some other elements which is molybdenum. There are other kind of elements which is vanadium. There are another kind of material which is titanium. All these 5 elements combined together, and sometimes a single element can give you better characteristics, wear characteristics, some kind of impact also it happens in different kind of fans. So when you select material for casing as well as the fins of the fan, you need to have a standardized practice of using it. It's not that you go there and you give it this kind of material. You should have a standard practice of using. Sinter plant will have this kind of SOX is there, NOx is there, what kind of dust they are generating. Accordingly, you should have a standardized practice of ironing. There is a practice called Z65 test. Z65 test, it should be standardized. In your cases also, if you are using this kind of standardized practice, you need not go to the expert. You have HRC 58 to 62, like hardness of this material.
Right.
And you might be thinking about the acicular ferrite. You are talking about microstructure. Acicular ferrite, or is there any martensite into it or any ferrite into it? All those things should be standardized. Then your fans will give you the life. I was asking about the life of the fan. At least you should give minimum of 10 years. Whatever be the ROI.
No, I think that typically the fans runs for 10, 15 years.
Yes.
Only the challenge is on the impeller, because it is rotating. Provide the right hard facing, choose the material, I think you will get that life.
What is happening in the sinter plants, because I was working in a sinter plant and pellet plants, there every 3-4 years their fins are being changed. And it is randomly, people are talking about chromium carbide, tungsten carbide, and finally it doesn't work more than 2 years.
True.
So if you are standardizing it and giving a guarantee of 10 years running fans, your road
Exactly,
is
sir.
open to you.
We have a very good solution for abrasive resistance in sinter plant. Definitely because of the material which goes into it, as you rightly said, those are expensive components. So it is expensive, but it saves a lot of your time. And one is the machine downtime of the fan. But imagine you are shutting down your sinter plant or a pellet plant for the sake of doing a balancing or a replacement of the vane. It is huge. So this we have the right solution. We can provide you, sir.
Thank you. Thank you so much. Any
you.
more questions, please? So if there is no questions, I think you have questions. Right.
Good afternoon. Question to Danieli. You have told about this direct casting and rolling. So what your product differ from conventional hot rolling, in particular in mechanical properties?
Yes, the conventional hot rolling that you mentioned is about semi-continuous hot strip mill, right?
Yeah.
In which the slabs are cast separately, the slabs are cooled, And then or in case you could talk of hot charging nowadays, the slabs are being fed to reheating furnace. From the reheating furnace, they go to a mill. The mill typically is one roughing stand, which is reversible, and then there are finishing trains of 7 stands. Now, this hot strip mill, which is the mother of all rolling inventions, is that there is a big difference of gap between the roughing stand and the finishing stands. So which takes care of the transfer bar length. Sometimes the coil box is put in order to take care of that. But why do we do this? In order to consider that the temperature is reduced below the recrystallization temperature. In roughing mill, normally the phase transformation takes place above the recrystallization temperature. By the time it reaches finishing mill, it has to go below the recrystallization temperature in order to facilitate certain amount of the metallurgical growth. And such metallurgical growth, let's say from ferritic to benitic, this gives you the strength. And further, after the finishing mill, there is a laminar cooling where really the strength and the metallurgical properties take care. So the same concept is being put in the QSPDA that we talk of. So my QSPDA is in the general of thin slab casting and rolling. In case of thin slab casting and rolling, you do not have this liberty of going below the recrystallization temperature that happens before the finishing mill. And that's the reason why Danelli QSP is that we separate the rougher and the finisher. So we bring the advantage of your hot strip mill. That is, there is a possibility of decreasing the temperature before the finishing mill by having a transfer bar cooling. So which gives you the same benefits that you have of your conventional hot strip mill. But in case of hot strip mill, what happens is the slab thicknesses are 230 mm. So from 230, you are reducing to a temperature of 2 mm. And then in case of a hot strip mill, it is a really challenge to go below 2 mm. Even 2 mm is a big challenge because in case of coil to coil, the setup changes. Whereas in case of QSP, when I say you can go with endless or we can go with semi-endless, you do not alter with a setup. So mill stabilization gets very quicker, and once mill is stabilized, and imagine you're producing 2 mm coil in endless mode. That is, there is tension on your coiler, there is tension also on the finishing stand and also on the rougher stand. So you can have a full stabilized production without any cobbles. Okay.
And what about cost?
Cost-wise, for sure, you see the input is, I would say 140 mm. Let's say 140 mm is the input and you're producing 0.8 mm. On the contrary, you are having 230 mm slabs of ambient temperature. You have to shoot it to 1100 to 1200. Then you go to rolling passes, and one rolling stand will have a reversible pass. So loss of energy is dissipated during the process of rolling, and it has to be compensated with high energy. So typically, if you ask me, for a 90 mm slab as a thickness input to the QSP Dewey, and in coil to coil mode, it would be having 90 kilowatt hour per ton, which is much less. In case of endless, it is a little bit on the range of 150 kilowatt per hour ton, but it is worth doing in endless because you will get the thickness range in terms of 16 micron, then the flatness. So all these will give you a premium, premium when you sell it. In fact, there are certain applications also in China where it has been tried. Normally, the motors will require non-grain oriented steel. And one of the important features of a non-grain oriented electrical steel is that it has a superior flatness. It has to have a superior flatness, which is, of course, not developed from the hot rolling. There are processes on the downstream also. But even from the hot rolling, if you can substitute that with low carbon steel, it's all about having a magnetic, flux kind of a thing. So, okay, electrical, non-grain oriented or grain oriented, they have this difference of polarity. So even low carbon steel with a superior flatness can go into very cheap motors, where you can afford to have those losses. So this is also a substitution of, low carbon flat steel in certain kind of motors. So basically, to answer, the difference is a hot strip mill has a potential to produce grades above X80 API, if you call so. So this is one, I think as of now, it is possible. The second was interstitial free auto exposed grades. But now with Danelli, we have the plant that we are mentioning, SSAB Luleå. There we will be able to produce even auto exposed grades. We have an offline scarfing machine planned. Once the slab is taken out of the tunnel furnace, it can be scarfed, put it back into the line. Again, there are induction heaters to raise the temperature. So once it is successful, then I think the difference will remain only with API grades above X80.
Sir, capital cost?
The capital cost, if you talk of TSCR, why? It is less than the hot strip mill. For instance, from the caster till the down color, we are talking of 380 meters, whereas a hot strip mill is around 500, 550 meters. Then you talk of bigger housing stands for sure, because you're reducing from 230. So you can say that a TSCR is typically less by say 30, 40% than what you invest for a hot strip mill, only on the OEM package. Hot strip mill will require more of water. So water treatment plant, the cranes, the crane capacity increases. If the crane capacity increases, your structure column increase. The structure column will mean more of civil foundation. So overall, there is a big difference in the total cost of ownership. If you talk of total cost of ownership of a let's say 1.5 million ton HSM versus a TSCR, a 1.5 HSM can be around, let's say, close to 2,000 crores. I would suggest, I'm giving a rough number, while here you can think of closing down your total project by around 1,000 crores. Because the water treatment plant becomes less. The descaling effect is less. So it's, I mean, there are various advantages of having it direct casting and rolling. But why in India direct casting and rolling was not so successful after 2013? This can be a question, because the last was in NMDC sold by us, and previously there were few of in Tata Steel and Hazira. The problem with that was it was only possible to roll certain cheaper low grades, that is low carbon in particular. But then the demand goes for high strength alloy steels. So one thing, as I mentioned, when you have this thermomechanical rolling possibility in your mill, you can produce coils above 500 megapascal also. And the definition there starts with specialty steel. The moment you're able to have a yield strength of 500 megapascal, you go with high strength steel, and that is possible with our mill, which was until now not possible with the conventional thin slab casting and rolling. Yeah,
Thank you.
Thank you, one and all. The session has really gone well. As we have started with Sankodeep Datto, it's a blowing the conch, the starting of the seminar. As his name says, Sanko means conch, And then we have gone to Narsimham, which is one of the one avatar from Dasavatar, which we believe. And then we have the engineer god, two engineer god, Vishwakarmas were there, And then finally we have brought the total thinking, a Kranti. Kranti man has given a very good lecture on the lubrications. And finally we have ended with Srinivasan God Balaji. So this whole session is totally, summarize the things. So thank you one and all. It was really being present with the dignitaries, and I think session is open for discussion and more of lunch. Thank you so much. Absolutely, please.
Hi, good morning, good afternoon. I'm Ajay Tambe from Steel Group. I have a question for my good friend Umesh. Umesh, one thing I want to ask you, because of this sustainability and new development, whatever happening, and Becker is doing very well in that. So what I feel that, what is your idea, or what steps Becker or other paint companies are taking to bring these new concepts to the ultimate users, like architects, like the I'm finding it really very difficult to bridge that gap, and ultimately every conference we are talking the same, but the things are almost stagnant. I feel that the stakeholders like Becker has to take some concrete steps in this direction. What's your opinion?
Yeah, you are absolutely right that we also find it very difficult to move the product across all the stakeholders and take a firm decision, because in India, the law is not so strict right now. Just I talk about like the chrome-free primer and the PU primer. I mean, in many countries it's banned. We cannot use the chromated primer over there. Even for the exports to countries like Europe and somewhere else, you cannot have the PU primer. You need the ROHS compliance and REACH compliance primer. So idea is to first to create the awareness through this kind of platform, collaborate together with the coil coaters like Apollo Steel is there, and many other coaters who are very active in promoting the sustainability, and take step by step, very small steps, like first convert the, I mean, whatever is in our hand, like convert the primer to the comfy primer, then we can use the low PMT paint system. Take small steps first, and then we can see the larger picture. So definitely it will take some time, but surely the awareness is there and demand is there. We are also thinking about to approach the agencies like Indian Green Building Council, then Griha. Then we can also, approach the government to form some kind of legislation to make some law to make it more stringent and to use for it. Thank you. I hope to answer.
Thank you so much. Can we have some big round of applause for our chairperson as well as all the panelists? I request Ankit sir to please come and hand over the token of memento and honor, starting with our session chairman, Dr. Arghya Majumdar sir, Director, School of Mines, Kazi Nazrul University. Can we have some louder applause? Thank you so much, sir. To our panelist, Mr. Shankhodeep Dotto, President, Business Development and Manufacturing, Picker Energy Asia. Thank you so much, sir, for being over here. To Mr. Narasimham, sir, General Manager, Tech Sales, Hot Rolling, Daniel India Limited. Thank you so much, sir. Can we have some louder applause, please? To Mr. Ashok Vishwakarma, VP Quality Assurance, APL, Apollo Building Products Limited. Thank you so much, sir. To Mr. Pramod Almore and Mr. Kranti Chittihoti from Kluber Lubrication Private Limited. Thank you so much to both of you. To Mr. Umesh Vishwakarma, DGM Sales and Marketing, Berger Becker Coatings Private Limited. To Mr. Umesh Vishwakarma, DGM Sales and Marketing, Berger Becker Coatings Private Limited. Thank you so much, sir. And to Mr. Srinivasan Krishnamurthy, Managing Director, Paul Rich, India. Thank you so much, sir. So we end the panel over here. Over to you, Ankit sir.
Thank you all for coming, and we are now at the end of our session and also at the end of our two-day conference. First of all, thank you all for showing up also in these difficult circumstances. Thank you all for showing us your support. I would like to firstly thank all our sponsors, our title sponsor, Yogi DG, our gold sponsor, Mastrol Pro, our silver sponsors, Jindal Steel and Power Limited, JSW Steel Coated Products, Larsen & Toubro, Flowchar, our roll grinder partner, Maxis Motion Control, our dinner sponsor, Calfreeza India, coated product partner, GTZ India, refractory partner, RHI Magnesita, delegate kit partner, Megatherm Induction Limited, and our co-sponsor, Fizstein. And also, I would like to thank all our panelists, not only today, but from both the days, all you delegates for being here. And with that, I would like to close this session and the conference. You can now go upstairs for, we are serving lunch in the same venue as where we had the dinner yesterday. Thank you all for being here. And yeah, that's all from my end. Thank you.